Hey guys, and welcome to the first Python video where I teach you everything you need to know about Python in a series of videos. So let's get started. The first thing you need for Python or any other programming language is an IDE. Now, what is an IDE? An IDE stands for Integrated Developer Environment. So why do we need IDEs? An IDE usually comes packaged with a text editor where you type, edit your code, etc., and a compiler slash interpreter which converts your code to machine language and an executable file. Now, some of the popular Python IDEs. I'm going to go through two of these, how to install. The first IDE is Anaconda. Now, how do you install Anaconda? Go to your internet browser, Chrome, Firefox, etc. I'm going to use incognito window. Go to anaconda.com. Get started. Install Anaconda Individual Edition. Download 64-bit because mine is Windows 10 64-bit. Wait for the download to finish. So my download finished. I'm going to open it. You'll get the screen. Click next. I agree. Just me, it's better. Or if multiple people are using your computer. Next. Browse your browse wherever you want the files to be installed. I already have it. So next. Uh, these aren't necessary. Install. I already installed it, so I'm going to close it. So what's the great thing about Anaconda? It comes with multiple IDEs. One is a notebook, another is called Spider. So you open your start menu, search Anaconda, Anaconda Navigator, open. Now this is the Anaconda Navigator or menu. So Jupyter Notebook is widely used and Spider. These two things are mostly used. I want to launch Spider and Notebook. So this is a Spider environment. This on the left is where you write the code. The bottom right hand corner is called the console where you'll see the output of your code if there is any output. And the upper right is just used to drag files, select files, etc., etc. So this is the code I wrote long back as my project. It doesn't utilize the console output, but this is where you run your code. It says run file, whatever file you had, and this was the output which I made. It was a GUI. Next we go to Jupyter. Now Jupyter uses your internet browser. So here you go to new Python 3. This is a notebook, which means you can execute your code line by line. It's like an interactive shell. So I write print hi, shift enter, This is how you run the code. You can see the output here, high, uh, 3 plus 4, 4 plus 4, 8. So you can see the output. Now you don't have to go to the Anaconda menu each time to launch these things. You go to your start menu, you can just search it, see it appears, or you want Jupyter. See? So that's one IDE. The next IDE that we're going to look at is called PyCharm. To download that, you go to jetbrains.com/Python. You click download. The community, because you have to pay for the other one. The download automatically starts. We wait for the download to finish. As we wait for it to finish, I'll show you another way. You can open command prompt, and that if you type Python 3, because it's 3.8, the latest version, you open this interactive shell and you can type anything. You get output in the next line. Suppose you type Python 3 and this doesn't show up, you can go to your Microsoft Store. If you're on Windows 10, search Python 3.8, click this and install. It's already installed on mine, so I'm going to close this, close command prompt. Download just finished, so I'm going to click open. Next, change my installation location. Create desktop. Next. Yes. Okay. And wait for it to finish installing. So I finished installing PyCharm. Finish. I click it. I confirm, continue. Don't send statistics. Skip remaining. Set defaults. New project. Location, okay. Create. It tells you the shortcuts right away. Search everywhere, project view. Okay. Don't show tips. Close. It's loading. So you can use the terminal right now. I don't know, print hi Python 3 print hi. So you can use the terminal of PyCharm right now. We won't get into files so soon. Suppose you don't like using IDEs and installing them and using them, you can always use online interpreters, but I don't recommend it. So two of the interpreters I suggest is programmers.com /python -programming /online -compiler. Hope hopefully I typed it correctly. And you can see it here. The left side is our text editor where we type our code, and the right side is our output console where you can see the output. You click run and you can see hello world. Another online compiler that you can use is online gdb.com/online underscore python underscore compiler. Now Python uses an interpreter and not a compiler, so this is technically wrong. So you click run. The output console is at the bottom this time. I ran it. You can see the output here. It says hello world. Other OS users like Linux, Unix, Mac OS, I have Ubuntu here. So what you want to do is open terminal, which will be here, and terminal you can click on it or press Control Alt T, which opens it up. For Mac it's Command Alt T, so you type Python 3 and you can get into the interactive shell. Oh, so that's all for IDEs. I'll be linking more IDEs and online interpreters and more useful things in the description. If there's any doubt, leave a comment, and thanks for watching. In this series, we're going to be using the Python 3 interactive shell, which is available in command line on Windows and terminal on Unix and Linux flavors. In this video, we're going to be seeing the data types of Python and the variables in Python. First, there are plenty of data types supported by Python. First data type is an integer. An integer is a positive or negative number which doesn't have a decimal. Now the range of integer supported by Python is negative 214,748,3648 to 214,748,3647 because the Python interpreter allocates 4 bytes of memory to an integer value. Now I'm going to be showing you an integer. X is equal to 5, print type 5. You can see a class int where int stands for integer. Next, we're going to be seeing float, which is any number with a decimal. For example, the value of pi. Pi is equal to 3.14159265. Now, the type, we can see a class float. Next, we're going to be seeing a character and string. A character is any alphabet A, B, C, D, or any digit, or those special characters like question mark, dot, underscore, hyphen, plus, equal to, etc., etc. The character is enclosed in single quotes or double quotes. In Python, a single character is considered as a string. As you can see here, str stands for string. Now, a string is a collection of characters. As you can see there, str, which stands for string. Now, there are many other data types supported by Python. Next, we're going to see the Boolean data type. The Boolean data type consists of true or false. For example, A is equal to true, capital T and capital F. As you can see there, it says bool, which is Boolean. The other thing that's in the Boolean class is false. Now, Python supports many other data types, but we'll see them in future videos. For now, I'll give you a brief explanation of each. First is a list, which is a collection of elements which can be of same or different data types enclosed in square brackets and separated by a comma. As you can see there, it says list. The next thing is a tuple, which is the same thing as a list, except once you declare it, it cannot be changed, and instead of square brackets, it's enclosed in parentheses. You can see there, it says tuple. The dictionary is a truly unique data type in Python because it consists of a key value pair. Now, the format is key colon pair value. It says class dict, which stands for dictionary. Now, another one is called a set. This is similar to list and tuple, but it cannot have multiples of the same element. If I put 1, 2, 3, 3, 3, says class set. Now let's see what happens when we print the elements of the set. Print set. As you can see, it deleted the multiples of the 3 and only one 3 is remaining. Next, we move on to variables. Variables is anything that holds a value. You use it to hold a value and to declare a value at multiple instances of your code. Now, suppose your code uses 5 multiple times. Each time you cannot keep typing 5, 5, 5. So you store in a variable called 5 is equal to 5. Now, if you print the value of the variable, or you can use it in other things. 5 plus 5, you can see 10. Now, there are multiple rules for declaring a variable. The first is a variable name can only have letters and digits and underscores. You can use a comma or a dot or a slash or a question mark and all these other characters which are not allowed. If I try to declare a variable with any of them, it says syntax error, which means it's wrong. After declaring the variable, you have to initialize a variable or assign a value to that variable. So 10 is equal to 10. Suppose I just declare the variable as in giving it a name. It says syntax error, which is an issue. Next, the first letter of a variable can be only of an uppercase or lowercase digit or an underscore. It cannot have numbers. So, for example, syntax error if you use a number. You can also have an underscore, which is allowed. The next rule, it's not really a rule, it depends on your interpreter. Usually, the length of the name of variable should not be longer than 31 characters. Now, there are two conventions that programmers use usually to name their variables. One is called camel case, where each letter of the new word is capitalized. The next is called snake case, where nothing is capitalized, but after the end of one word and the beginning of the next word, you keep an underscore. I forgot to initialize it. I usually use snake case and will be using snake case for the rest of this series. Now, the last rule of naming a variable is Python has 33 words which you can't use as a variable name. They're reserved for something else in the code, such as addition, logical operations, loops, conditional statements, etc. etc. I will be showing you these words and I will be linking them in this description as well. Now the syntax for naming a variable is variable name equal to then the value which you want to initialize to it. Now there are some rules of initialization and declaration, such as the name of the variable should always be to the left of the equal to sign and the value that you're going to assign to it should be to the right of the equal to sign. Thanks for watching, guys. In today's video we're going to be seeing input and output. Now, what do you mean by output? Anything that you want to be displayed onto the screen. We do this by using the print function. Now, if you want a sentence to be passed, you enclose it in double quotes and say, now you can see the output. This is the output that's displayed on the screen. Another thing you can do is store it in a variable. Now you don't have to enclose the variable in double quotes, you can just pass the variable as a parameter to the print function. For example, print x, you can see the output. Now this is all about output. Now we see the input function. The input function is where you have to enter something to the code. We do that by declaring a variable and using the input function. Now you can see it's blinking, which means it needs an input. You can type anything. Now if I print the variable that I stored my input in, it says hi. What do you pass as a parameter to the input function, as in within these parentheses? This The parameter you pass is whatever message you want to display that tells the user what kind of input or what input they want to enter. For example, I want them to enter a number between 5 and 10. So I type that. Since it's a sentence, it's a string, so you enclose it in single or double quotes. Enter a number between 5 and 10. Click enter. You can see the message that's being displayed, and I enter 5. It's a little unclear. I will do it again. If you put /n, which is \n, it tells the system to move on to a new line. So you enter your input in the next line, not in the same line. You can notice how it says 105 because I entered 5 as an input. So I enter it. Now it's asking me in a new line. I enter 5. Now if I print the variable I stored it in, it says 5. Now the last thing we're going to see is typecasting. So even if you enter a number or a float or anything using the input function, the type it's going to be stored in as is a string. So last time we saw the type function. So I entered 5 there, the variable hi. You can see it's str, which means string. It's not an integer, it's a string. So what do we do if we want a particular data type as input? Now I do the same thing, enter a number between 5 and 10, but I make it an integer value. To do that, I type data is equal to, data is the name of the variable, whatever data type you want it in, then input function, enter number between 5 and 10 /n because we want it in the next line. Enter. So I enter 5. Now if we check the data type of the input that we type now, I stored it in the variable named data. You can see it's class int, which means integer. Now the same thing you can do if you want a float value, you replace float. You replace int by float 5. Now we check the data type. It's float. Same thing with any data type. Suppose you want a string. Well, the default data type is string, so many people don't use that. So we use list. Now we open it. Class list. Set. It's of type set. So this is about input, output, and typecasting. See you guys in the next video. Thanks for watching.
Hey guys, welcome to the Python series. In this video, we would be learning what are the methods which can be used in strings. Methods used in strings. Let us know what is a method. Method is called by its name, but it is associated to an object which is dependent. A method can operate on the data, instance variables that is contained by the corresponding class. These are a few of the examples which are of the methods which can be used in strings. And those are .upper, .lower, .split, .format, .encode. There are multiple other methods which can be used in strings. I'll be showing a few of the examples. The platform I'll be using for this video will be Jupyter Notebook. So let's start. Text which are entered after the hashtag symbol is considered to be as comments. Generally, if you want to convey something informally, you can use this hashtag symbol and you can convey the information, and it would not be taken as inputs. So let us start with a few of the examples. I would say as G equal to, say, print hello world, and it would print hello world here. So here in this case also, which I've mentioned, whichever text I've mentioned between encrypted inside this inverted commas are termed to be as strings. Initially, all the terms inputted would be in form of strings regardless what type it is. In case you are inputting any integer or floating values, you should be specifying the data type beforehand. Say, I'll be showing an example. Suppose I say x equal to 1 2 3 4, and when I check the type of x, it would be showing me the output as str, which is string. So why does this show as str? Generally, whatever value or whatever text which is encrypted between the inverted comma generally would be given a string. In order to correct this, we be using the date type. So if I want this to be an integer type, I should be specifying int 1 2 3 4. Then this mistake would be corrected, and now when I check the type of x, it would be in integer format. So when I add up 2 plus 3, it will give me 5. So yeah, 2 plus 3 would give me 5. So if in one case, if I take 2 and 3 as strings, so if I take 2, 3 in form of strings, why does the output gives me 23 instead of giving me the output as 5? You know, right, 2 plus 3 will give me 5, but why is, in this case, why is it giving me 23? So this concept is known as string concatenation. When one, when string 1 and string 2 are added together, they're not added, they're generally joined together, so that string 1 and string 2 becomes joined to become a single string. So in this case 2 and 3 are added up because they're in the form of strings, so generally give you 23. Now let us go to an example of string concatenation. So I'll say A as hello, B as world, and let's say A plus B. So now the output will be printed as hello world. Hence, variable A and variable B are joined together and been formed into a single string. So for better understanding, let me assign another variable C for A plus B. So now let us go through some of the methods which can be used in string. Say C dot upper. With this dot upper method is used for converting all the given characters in a string into uppercase letters. So if I say dot upper, and all the given letters for hello world will be converted into capitals. If I just want to convert the first letter of the given string into capitals, I can use a method called dot capitalize. So if I use this, only the first letter of the given string would be converted into capital letter, and rest all will remain the same. So if I want to convert the first letters of the words in the given string, like suppose capital H and capital W, I'll be using a method known as c.title. I'll say the title, sorry, so I say c.title So here, this would be converting all the first letter of the words in a given string into capital letters. Hence, as my string hello plus world is clubbed up into a single string, my the first letter of this hello world would be H. So dot lower is used to convert all the given characters in a string into lowercase letters. So here, head hello world, all the given characters in hello world are converted into lowercase letters. There's one more method which is similar to dot lower, which is dot case fold, which also serves as the same. It also converts all the given characters in the string into lowercase letters. Dot center method is used for when you want to place or you want to position your string in a line, or so you want to position your string in a line in exactly at the center position. So suppose you are indexing the given string in an index of positions of 25 and you want your string hello world, or for example any other string, to be positioned exactly at center, you can use this method dot center. So I would be positioning this string hello world in exactly in the center position of an index of 25 positions. So I'd say c dot center. As you can see, there are white spaces before and after hello world, saying that there are 25 positions from here to here. So hello world is placed exactly in the center of this indexes of 25 indexes. Dot count is to find out how many counts a particular attribute has. So I want to say, I want to find how many O's are there in hello world. So as you can see, if I type O, the output would be 2 because there are 2 O's in hello world. Dot encode is to check out and is used to return an encoded version of the string. So here I want to find which type of version is my string encoded. So I'll be saying type C. So I can find out that it is in string format, and my encoded version could be found out by using typing this C dot. Here you can see the encoded version of my given string is in the form of bytes. Here c.find is used to find out the position of a particular attribute in the given string. So if I want to find out the position of character E in the string hello world, I can use this method .find. There's a similar method similar to .find, which is .index, would we find the position of the index of the given value. So here is give me 1. So according to the indexing procedure, starting letter as character would be termed as 0, the second as 1, third as 2, fourth as 5, and so on. So here E is the second letter, so it would give the position as 1. So dot is alpha is used to check whether all the given characters in the given string are in alphabets. So if all the alphabets, it would give the output as true. So each digit is contained. Just check whether the given digits in the given string. So if there are no digits, it would give the output as false. So here dot is decimal returns true if all characters in the string are decimals. So in this case, C, which is hello world, doesn't contain any decimals, so the output would be false. Dot is digit is check whether all the characters in the given string are in digit format. So in this case, all the digits are not in digit format, they're in alphabet, so it gives the output as false. This dot is identifier method is used whether to check whether the given attribute, given string is an identifier or not. If it is an identifier, then the output would be given as true. But is numerical is to check whether the given string are all are in numeric. So here it gives out false. Hence, hello world are in alphabet. So hence it should give me false. If all the given attributes or the characters in the given string are printable, then the output should be given as true. So hence all the given characters in my string are printable. So hence my output would come as true. Dot space returns true if all the characters in the string are white spaces. So if all of them are white spaces, hence the output for the given would be true. For example, I'll be showing you f and say, yeah, sorry, it is f, not c. So say, so here all are white spaces in the given string f, so it would give the output as true. Dot is upper method uses to check whether all the given characters or attributes in the given string are in capital letters. So only the first letter in the string hello world is capital, the rest all are lowercase, so hence the output would come as false. So I'll explain about another method, which is strip method. In order to explain this, I would have to assign a variable with white spaces before the string and after the string. Let's say L equal to space hello space. So here I would say L dot L strip. So here L strip method is used to remove the white spacing which is provided on the left side of the string. So it will remove all the white space which are provided on the left side of the given string and printing out everything else. And if I want to remove the spaces which are provided on the right side of the string, I'll be using the method rstrip, which removes the spaces in the right side of the string and prints everything else the same. And if I want to entirely remove all the spaces, then I would be using the method strip, which removes the entire spaces on the left and right side of the string. So now I will be explaining about the method dot replace. So for this, to assign one the variable, I say h equal to high, and I say c dot replace, and I would replace, as you know, I had given c equal to a plus b earlier. Now I would replace that a with h, with in the sense I hello world, which was printed earlier for c equal to a plus b, now it would print hi world. Here, dot starts with method is used to check whether the given character in the string prints out the first letter. So it returns true if the string starts with a specific value. If my here the specific value is e, so my string doesn't start with e, it starts with h. So the output would. Hey guys, welcome to the Python series. Topic of this video is gonna be on integer method. So let us go through the definition of integer method. The integer method returns an integer object from any number or string passed as an argument, or returns 0 if no arguments are given. Here is the syntax for the integer method. It's given as int x equals 0, base equal to 10. An integer object can be any number or string, treats the default base as 10. So if there is no argument which is present, then the output would be written as 0. So let us start with some of the examples for the integer method. Let us say a variable a, and I'll assign the variable a with value 54. Here 54 is an integer. So let me check by using this statement type, say a, and here you can see the output as int. So let me give you another example, say b as 10 by 4, and when I check b, it will give me 2.5, which is a floating type. So by checking type, I can get to know that it is a floating type. So in order to convert this into integer type, I can use a method like I say b equal to 10 slash slash 4. This method is known as integer division. By providing another slash along with the given slash, it would convert the following output into integer type. So here it is converted to integer type. Or you can also convert it into integer type by providing the data type int. Let us say int and say 10 by 4. By doing this, this converts the following their floating value into just the integer type. It would just print the integer part of the given output 2.5 and it gives you the value 2. Suppose one case I want to find the type of the num by using the statement type of the num is, and let's say I want to check the type of a which I have already assigned above, say, and I've assigned it as 54. So here it's showing the type of the num is integer, and yeah, the value 54 which I've assigned is an integer form. So if I assign another variable num saying that 1 2 3 4 5, as you know, we have learned in the previous video, anything which is specified within the inverted comma is considered to be a string. So if I deliver this in the above statement, type of the num is, and check the type, it will show the type of the num is in class string. So if I want to convert this whole statement and print the given number in integer format, I should be specifying the data type int. By specifying this data type, now by specifying this int data type, the given following string would be converted into integer type. So by checking out with the above statement and say type num. Here, as you can see, the type of the given num is in class integer type. So here, by specifying the type data type int, it is converted into integer type. So let us go through one of the exercise. Let me give you another example by saying that x equal to int and say input and say \n, and I would be giving the first integer to be as 10, and let us say another variable y with int say \n, and now if I say 20, and now if I take another variable z, which is addition of the following variables, and say print z, it would give me the output 30, which is addition of following variable x and y. So as in the variables x and y are specified in the data type int, so the output also would be printed in the integer format. I hope you guys understood the following concept. Thank you guys for watching this video. See you again in the next. Hello guys, welcome to the Python series. In this video we are going to learn what is a float method. So first let's start with the definition of a float. The float method is used to return a floating number from a number or a string. Here you can see the syntax of the float method. The method only accepts one or more parameter and that is optional to use.
So now let's start with some of the examples for float method. So I'll be taking a variable a and I'll be assigning a number 12.36 to the variable a. And now let me check the type of a. So here it's showing the output as float. So the number which has been assigned to variable a is a floating type. As you can already know, this is a decimal number. So the type of the given number would be a floating type. Suppose I want to know the percentage of a particular candidate in floating value. Let me take his name as Alex, and I would say his result to be as this, and let me print. So here you can see his name and his result has been printed here, and name as Alex and his percentage to be 92.6000 and so on until 1. So here it's printed in the floating value. Basically, now I'll be explaining few of the examples which can be used in floating type, which are absolute, floor, field, and trunk. Now let us go with the first method, which is absolute. If I mention integer inside the parentheses, so the output would be a whole positive integer of the given number. So here, if I say absolute 5, here it would still print me 5. If I say absolute -5, it would print the absolute whole positive integer of the given number. So now I'll be telling about the method round. So if I specify my given number, let us say 3.568 and comma, and here I'll be specifying the number until where my decimal place is going to be up to. So if I want it until 2 decimal places, I should be mentioning 2. So if I mention 2, here it will be rounded until 2 decimal places. So 3.5678 is rounded until 3.57, which is until 2 decimal places. In order to explain the methods which is floor, seal and trunk, I'll be import using a keyword known as import, and by importing a module known as math, we are making it available to us in this current program as a separate namespace. So I'll be importing math module. So let us say math dot seal and say 5.6. So here it rounds a given number to the next higher integer. So the next higher integer for 5.6 is 6. So it prints out 6. It's also applicable for negative values. Let us say seal and say minus 1.3. So here, as you know that minus 1 is greater than minus 1.3 in negative scale, it prints out minus 1. Now let us know about floor method, which is just the vice versa of what you have seen in seal method. Suppose I say 7.2, it prints out the next lower integer of the given number. So the next lower integer of the given number, 7.2, is 7. So it is all in this case also it's applicable for negative values, and say minus 2.1. So here it prints out the next lower number, which is minus 3, with rounded number of minus 2.1. And now go to the method which is trunk. By using this method, we would be obtaining just the whole integer of the given number. So here the integer part of the given number 4.5 is 4. So here it will be displaying only the integer part of the given number. It is also applicable for negative values. Let's say minus 4.5. So it just prints out minus 4, which is the whole integer of the given number minus 4.5. So now let's talk about float formatting. So when you end up having long decimal places, decimal values, as you can see in this case, where I wanted to print out the percentage of a given candidate, and I ended up getting his percentage in such a long decimal value after this point, long decimal values after this point. So in order to correct that, and if I want to specify and restrict it to until some decimal places such as until 2 decimal places or 3 decimal places, I'll be using this formatting method. Let us say my number is 2578.1529. I'm just taking a random number, and let us say the formatted number is so dot 2f is used to restrict the given number until 2 decimal places. This dot 2 is used to restrict the given number until 2 decimal places. If I want my number to be in currency value, I can use this method. So here the given number is printed in a currency type. So here you can see it is 2578.15. If you want the number to be in exponential notation, you would be using this method. Say formatted number equal to format. So by using this 2e, it would restrict the given number until 2 decimal places, and the rest would be printed in exponential form. So 2.58 and rest in EPUB 3. So here, as you can see, it doesn't matter whether it's small letter E or capital E. Instead of small e, it would print capital E if I specify capital E over here. Let me show you. So if I type in capital E, it would print out in capital E instead of small letter e. So I hope you guys understood all the concepts in this given video. I'll see you again in the next video. Thank you guys.
Hello everyone, welcome to the Python series. In this video, we are going to talk about what are lists. So first, let's get to know the definition of what is a list. Lists are ordered sequences that can hold a variety of object types. They use the square brackets notation and commas to separate objects in the list. Lists support indexing and slicing and can be nested and also have a variety of useful methods that can be called off to them. These are two of the examples for what is a list. Here you can see 1, 2, 3, 4, 5 are numbers which are denoted in square brackets, or you can take these alphabets A, B, C, D, which are denoted inside the square brackets, are examples of what is a list. First, let me take a list known as my list, and I'll specify the given items in the list. So I can specify the given items in the square bracket notation, which will represent to be a list. So when I just check the type of my list, output would be shown as list. So this is an example of a list. So I can also check the length of my given list. So just type in len and just type the attribute, name of the attribute, and it will be specifying the length of the given list. So here there are 3 items in my given list, so the length would be 3 here. So I can also rename my given list, and I'll say I'll take my list to be as 1 and 2 and 3. So I'll give 3 items in my list to be 1, 2 and 3. Now I want to retrieve the first item from the given list. So I'll be specifying the index of the given item, and I'll be retrieving the first item from the given list. So the first item is indexed with 0, so I'll be retrieving the first item, which is 1, from the given list. So if I want to retrieve the other items apart from the first item, I'll be specifying to be like 1 semicolon. So here the number which is specified before the semicolon is known to be start operation, and after the semicolon is the stop. So I'll be starting from 1, so 1 until the end. So 1 is 2 and it will stop until, and it will print until the end. So I have not specified any stop, so it would print until the end. So here you can see that I have not specified any stop, so it will print 2 and 3. So in case I specify stop and I say 1 semicolon 2, it will print only the 2, and it will print until the index 2. So it will not print the second indexed value, which is 3 in the given list. So it will print only 1 and only 2, which where I'm specifying 1 index. So 1 here is 2 and 2 indexed is 3. So it will only print 2. Let me take another list, and I'll take it as 4 and 5. So when I add both the lists together, so suppose I want to add these both lists, so my list and this particular list, which is another list, and I'll add up these both lists, and these both, the attributes and the items in both the lists will be combined into a single list. So you can see that the attributes of another list and the attributes in my list are added and given in a single list. So I'll name this as my new list, and I'll specify it as my list plus another list. So now when I type in my new list, it would show me all the attributes in the given list. Suppose I want to replace a given item in the list with an other item or any other attribute. So I'll be specifying the index of the particular item. Suppose you say I want to replace the first item in the given list. So I'll be specifying the index of the first item. So the first item is 0. So I'll be specifying the index of the first item, and I'll be mentioning which I want to replace with. Suppose I want to replace the small lettered 1 with the capital lettered 1. So I'll be specifying it, and here you can see that when I type in new list, my new list will show the capital lettered 1 instead of the small lettered 1. So now I'll be explaining about some of the methods which can be used in lists. So this is an example of a method. .append is a method which is used to add a particular item to the given list. So I'll be specifying the item which I want to add by this, and the new item would be added. So when I just type in new list, I can see that my new item, which is 6, is added to the given list. There's one more method which is known as .pop, which is the method which is used to remove a given item from the list. So I'll be specifying if I want to remove 3 from the list, I'll be specifying the item which is supposed to be removed and say pop. So I should be specifying the index of the particular attribute. So I say pop and I say 2. So the item which is indicated with the index 2 would be removed from the particular list. So now I check in my new list. Here you can see that attribute 3 is removed from the given list. So if I don't specify any index value, it'll just remove the last item from the given list. So I am not specifying any index for the given item, so it will just remove the last item from the given list. Now when I type in new list, it will display all the given items except the last item. So item 6 would be removed from the given list. Let me take an example. I say alpha list is A comma B comma X comma So suppose I want to sort out the given alphabets in the particular list. So I'll be using a method known as alpha list dot sort, which will sort the given alphabets in the particular list in alpha list in alphabetical order. So when I say alpha list, so all the given letters in the list are arranged in alphabetical order. I can also arrange the numbers in numerical order by just specifying the dot sort method. So by doing this, all the given numbers in the given list would be arranged in numerical order. You can also use a method which is dot reverse, which will reverse the order of the given arrangement of the items in the list. So when I use dot reverse, all the attributes would be reversed in the given item. So all the attributes or the items would be specified in the reverse order. So I hope you understood all the concepts in the given video. We'll see you next time. Hello guys, welcome to the Python series. In today's video, we are going to discuss about two data types, which are tuples and booleans. First, let us look into what are tuples. Tuples are very similar to lists. Tuples use parentheses, whereas lists use square brackets, but they have one key difference, that is immutability. Once an element is inside a tuple, it cannot be reassigned. For example, you can see this tuple 1, 2, 3, 4, 5 and A, B, C, D are examples of tuples. Now we'll be seeing about the bool method. A boolean expression is usually represented by two values, which is either true or false. So you gotta make sure that the values are capitalized, or else you'll receive an error showing that the name is not defined, the respective name is not defined. So this is the syntax for the boolean method, which you can see here is bool, and inside the parentheses you'll be mentioning which parameter you'll be using. Example, string, it could be string or an integer, etc. Hey guys, now we'll see some of the examples for tuples. So let us start with the first example. So as you know that tuples are represented by parentheses, and take an example of a list so that we can compare what are the common options available in lists and tuples, and what is the difference between these both. So when I check type of T, it returns back saying that it is a tuple. So I can also check that for my list. So it would return me saying that it is list. So we can also check the length of the given tuple, similar to that of list. So we say length T. So it would give me the output as 3. So there are 3 items which are there in my tuple. So of course it will give me the output as 3. Just like list, it can have mixed object types. So if I assign my tuple that 1 and 1. And just like list, I can grab a particular item by specifying its index value. So if I type in the index value of the particular item, it would give me the item which is placed at that particular position. So reverse indexing also is possible in tuples. So it would just give the item which is placed at that particular position. There are two built-in methods which can be used in tuples, that are count and index. So here you can see that there are only two possible built-in function methods which can be used in tuples, that are count and index. So I'll be showing you the first method. So let me take an example saying that I have a box and cards and box and cards and box. So I want to know the number of boxes present in my tuple. So I'll use the method count and specify the item to which I want to get the count of. So I'll say box. So I'll get the count of number of boxes which are present in my particular tuple. So now we'll check out the method index. So I'll be specifying the item which index value I have to find. So I'll say box. So it returns back the value of the very first box indexing which is present in the tuple. So it doesn't give the other index values, but it gives the very first index value of the particular box which is present in the tuple. So if I try that for cards, so it would give me the very first card index position present in the tuple. So I want to replace an item with another item. That is possible in lists, but if you try item assignment in tuple, it would not be possible. Let me show you how. So if I try item assignment, saying that I want to replace small lettered 1 with capital lettered 1, it shows me a type error saying that tuple object does not support item assignment. So you would be getting a question in your mind saying that tuple has very less methods and you can't even do item assignment. Then what's the use of using tuple? Later on stages as a programmer, you will see the actual benefits of using tuple. Tuples is one of the most important data types in Python. It protects data from manipulation. Try to delete some item or element from it, you'll not be able to do it. Or in this case, you can see that you are not able to change an item from the given tuple. So, which is essential when you really want your data to be secure or you don't want it to be deleted by mistake. Computers are made in such a way that they can understand the binary languages, which is usually made of ones and zeros. While Python has several numeric types, there is only one logical type which can be used, that is booleans. There are two possible ways for booleans. It can either be true or it can be false. So you have to be careful that you are mentioning whether it's true or false. So both true and false are capitalized in Python. So if I say, so I can assign, it is basically used for comparison operations. So I say A is 5, B equal to 3. So if I want to compare between two integers, I'll generally be using the double equal to symbol, which is denoted by this. So here you can see that it says false. A is not equal to B. So if I try the exclamation mark, which is considered to be not the logical not in general programming languages, and you check now you can see that it shows you a true. So basically it gives you true or false based on the requirement. So if you're having a valid statement, then it would show you true, or if the statement is wrong, or then it will show you false statement. So you can also use to compare, so saying that to check whether it's greater or equal to. So I can use whether the greater or less than symbols here. So I can say that if A is greater than B, so to check that it shows true. So I'll be checking out for A less than B. So here you can see that it shows you false. So when you inspect the type of true and false, you can see that it is denoted by bool. So let us check for type false. Now let us check for type false. So it will show you that it's a bool operator. So bool method can be used for a given attribute to be converted into integer or a string value. So when you want to using the bool, you can say that a number or a string can be converted into booleans. So let me check 2.5. It will show you true, so it's a bool. So bool minus 1.8. So it shows you true. So if I check bool of 0, it will show me false. You can also convert strings into boolean. So I'll say hello there inside string, so it will show you the output true, and also an empty string with just the space involved in it, it will show you true. But if you enter an empty string without anything, so it will show you false. So empty string show you false. So this is the bool method. So I hope you understood both the concept which has been explained in this video. which is tuples and Boolean operators. Thank you guys for watching. I'll see you next time. Hello guys, welcome to the Python series. In today's video, we'll be talking about the data type dictionaries. Dictionaries are represented by curly brackets, and a dictionary is a collection of elements which is unordered, changeable and indexed. So objects retrieved by key name. So here the elements inside a dictionary are considered to be a pair of key and its respective value. So here the elements are unordered and cannot be sorted. So the syntax is as shown here. So dict and parentheses and the keyword arguments. Now we'll be trying out some of the examples for dictionary. Let me say that my dictionary is named as dict1, and dictionaries are usually represented by curly brackets. So let me type out the elements inside my dictionary. Dictionary usually represented in the form of pairs. Pair in the sense a key and its respective value. So this is my key and the value is 29. So item 2. So I'll be giving this item to value to be 40. So when I check dict1, so it will show me the elements which has been stored in the particular dictionary. So by checking the type of dict1, I can see that it is of class dict. So if I want to grab 40 from this dictionary, so what should I do? So I'll be specifying the key name of the value which has been stored in that particular key. So I'll specify the key name. So in this case you are specifying key weight. Generally for other data types we'll be considering this as indexing, right? But in this case for dictionaries we'll be specifying the key name here, and it will give me the output, giving the output as the value which has been stored in the particular key. So it will show you the value which is stored in this key item 2. I can also have other data types such as lists, sets, tuples inside my dictionary. So let me show you. So let me take my dict2 and k1 is 1 and k2 is 2 and k3 is, so I can have a list inside my dictionary or a tuple inside my dictionary. So if I want to grab out this element 2 from this dictionary, what should I be doing? So I'll just say I should be mentioning the key which has been stored. So first I'll be mentioning the key where the list is stored, so it is k3, and then I'll be specifying index of the particular number. So the index of this number 2 is 1. So when I type in this, I'll retrieve the value 2 from the list 1 to 3 and from the key k3. So I can also have a dictionary inside a dictionary. In other words, you can call it as nested dictionary. So let me take a dictionary 3 and assign it with the following values. Key 1 is 1, key 2 is 2, and key 3 as 1, 2, 3, and key 4 as another dictionary which I'll name it as key 5 with 5. Yeah. So now if I want to grab out this 5 from the dictionary 3, so I'll be specifying the key, the main key which has been, in which the particular value has been stored. So here the chain, I'll take the first key, so the whole dictionary which has been stored in the particular key. So this dictionary, this small dictionary, is stored in the key4. So I'll be specifying the key k4, and now I'll be specifying the key in which this value has been stored, that is k5. So now I'll retrieve the value 5 from this particular dictionary. So we can also add elements inside the dictionary. Let me show you. So if I have an empty dictionary, so if I want to add elements into my dictionary, I'll just say k1, and I'll assign a value for this k1. So the particular key value pair has been stored in the particular dictionary. So I can also add in more elements. So the values has been added into the particular key. So I can also replace a particular value which has been stored in the key to another value, a new value. If I want to change 2 to some other value, so I don't want 2 for the value which has been stored in the key k2, so I wanted something else, so I can replace the particular value into some other value. First I have to mention which value, which key I have to change the value. So I'll say 2, so and new value will be 3. Now my key k2 will be having the value 3 instead of 2. Now let us try out some of the methods, built-in methods which can be used in dictionary. So d.keys is a method which will give you the output of all the keys which are there in your particular dictionary. It returns all the keys which are there in the dictionary. d.values returns all the values which are there in your dictionary. You can use a method d.get. d.get, and you should be specifying the key name. So let us say key1. So it will give you the value which has been stored in the particular key k1. So now let us try a method copy. So in order to do this, let me take my new as dict2, so my original dictionary is gonna be k1 1, k2 2, and k3 3. So my new is just gonna be the original dot copy. So when I check new, it'll just get a copy of all the values which is be stored in the original. So it will display the copy or the value copy, the key value pair copies of the particular dictionary and the elements which is be stored in the dictionary original. I can use the method dot items which will return me a list containing each key value pair. So it will give me a list of all the elements or as a key value pair as a whole. So here this is a pair of key k2 and 3 and a pair of key k1 and 1. So d.pop is a method where I'll specify a particular key. Let me say key k1. So the value key pair of the dictionary D would be removed. So here k1 is been totally removed. So Let me add an element inside. Let me add it again. So in order to explain the next method, um, yeah. So now if I want to pop an entire key, like so, this method pop item is a method which pops out the last key key value pair from the given dictionary. So now my key will only contain the first elements of the dictionary, and the last key value pair would be removed from the dictionary. So I can also use a method known as date, where I can enter my key. So let me enter it up. So now when I type in D, the new key value pair would be updated into my dictionary. And there's a method known as dot clear. It clears out all the given elements from the dictionary, and now you'll have an empty dictionary. Hello guys, welcome to the Python series. In today's video, we are going to talk about what are sets. So let's start with the definition of what is a set. Sets are unordered collections of unique elements or a list of elements which is unindexed. In Python, sets are usually represented with curly brackets. Here is the syntax for set and parentheses, and we'll be mentioning the list of elements inside. So I'm going to take my set as my set, and I'll be mentioning all the elements in my set. So this is going to be my elements in set, and when I print my set, so it's going to show me all the unique set of elements which are present in my particular set. So the repeated elements such as 3 or 4, or these elements are not going to be shown. The second copy of a particular element would not be shown. Only the unique set of elements will be printed in your set. So I can also use a set constructor to prepare a set from a list of elements. So I'll say my set 2 is gonna be set, and I'm gonna mention this list of elements. So this is gonna be my list. So here you can see this set constructor used to construct a set of which contains a list of a set of elements. So I can use len function to check the length of my particular set. So here you can see that my set contains 17 elements in the particular set. So I can use the dir method to return and I'll be specifying my set, and this method is used to find out the possible methods which can be used on sets. So these are the available methods which can be used on sets, and now I'll be showing you a few of the examples which can be implemented on sets. So I'll be demonstrating only a few of these methods which are available in sets. So first, let's start to how to add elements in your set. So let me take an empty set. So I'm going to be using the set constructor to add in the elements in my particular set, and I'll use the dot add method, which adds in a single element into your particular set. So if I want to add the number 3 into my set, now I'll print my set 3. So the element 3 will be added in your set. Dot update method is used when you want to add more than one element, a numerous number of elements into your set. Then you'll be using the dot, so or a list of elements basically. If I want to add in so here the list of elements will be added into your particular set. By using the dot update method, you can add more than one element into your set. So if you want to remove an element from your set, you can use the dot remove method. And specify the particular element. And that element will be removed from your set. And if you use a method dot discard, and you don't know whether an element which is present in your set is actually present or not. So when you try to remove an element which is not exactly present in your set, let us say the number 90, and it will show an error saying that the number 90 is not present in your set. So an element which is not present in your set can't be removed using the method dot remove. So in order to do that, to avoid such mistakes, you can use the method dot discard. When you're not sure whether the element is actually present in your set or not, and not exactly sure whether it's there, so you can use this dot discard method to avoid such kind of mistakes. And now if I try the same number with dot discard method, it doesn't show you any error as such. And you can use this method also to remove an element which is already there in your particular set. Suppose I want to remove the number 4, so I can use this method. So you can use the dot pop method, which removes a random element from your set. So here you can see that 1 has been removed from your particular set. I can use this symbol to find out the union of any two elements. So I'll be showing you. So my set and my set 2. So here it will show me the union of the two elements. Or we can also use the dot union method and specify the other element here, and it will show you the union of all of the particular two elements, two sets. So if you want to find out the intersection of any two sets, you can use this symbol, the and my set2. So here it will be showing you the common elements or the intersection of these two sets here. So, or you can also use the dot intersection method and specify your set2 to find out the intersection of into a set. So I can also find out the difference between two elements. Let's say my set2. So here it returns all the elements in my set and not the common elements in my set2. So if I do the alternate thing, which is my set2 minus my set, here it prints in all the elements in my set2 and not the common elements in my set. So if I assign my set4 to be a frozen set, then and try to add an element into the set. So here it says that frozen set object has no attribute add. So here frozen set method is used to secure the elements inside this set safe and avoid from manipulation. I hope you guys understood all the concepts in this video. I'll see you again in the next video. Hey guys, welcome to the Python series. In this video we are going to discuss about what is indexing and slicing. So first let's get to know what is indexing. An index refers to a position within an ordered list. So it basically retains a position of the given string or a value. Python strings can be thought of a list of characters. So indexing here uses the square bracket notation after the string. Indexing allows you to grab a single notation from the particular string. So here you can see the syntax of the indexing. So the character given here is hello, and H is indexed with 0, E with 1, L with 2, L with 3, and O with 4. And if you take it in reverse indexing, it can be characterized as H as 0, E as -4, L as -3, L as -2, and O as -1. Slicing allows you to grab a subsection of multiple characters. In simple words, a slice of the string. This is the syntax for slicing operation, which is enclosed in square brackets, start, stop, and step. Start here indicates the numerical index for the slice start. Stop is the index you'll go up to. Step is the size of the jump or the step size you're going to take. Let us do some examples in indexing and slicing. So I'm going to name my string as my string, and the code I'm going to use is hello world. Here, now I'm going to print hello world. So I should be specifying the variable in which it's stored. So I'll be saying my string. So when I check the type of my string, I should be getting str. So here, how the indexing concept is characterized. So here H is indexed with position 0, E with 1, L with 2, L with 3, O with 4, the space in between hello and world, and that is 5, W6, O7, R8, L9, D10. So if I want to grab a particular character from this string, I should be specifying its position or index position. So if I want to grab H, so I should be specifying its index position, which is 0. So it will print H. It will be giving the output h, which is positioned at index value 0. So if I want to grab r, I can either do it by two methods. Either by doing the straightforward method, which is index, by saying its position 8 and it would print r, or else I can use reverse indexing and say -2, sorry, it's -3, say -3, it would print r. So now let us know what is a slicing operation. So slicing operation basically represented by start, then stop and step. So I have my string this. So when I say 2 colon, so it would print all the values after the index, starting from the index 2 until the end, starting from the index 2 position until the end. Here the index position 2 is L, so it will print from 2 until the end. So if I use semicolon 3, so it's going to print until 3. So it's going to start from the initial position and it will print until the index value 3. Now if I mention 3 and 6, it would start from 3 and it would print until the index value 6. So here, now if I don't mention any index position, I just put 2 colon here, so it's gonna print from start to end. So I didn't mention anything, so it's going to print from start to end. So if I don't mention start and end and just specify the step size, which is this, so it's gonna print it in steps. So it's gonna print the first letter and it's gonna take a jump of 2 indexes and it's gonna print the character which is after the 2 index positions, and it goes on like that until the end. This is the actual syntax for so here 2 is the start, 7 is the stop, and 2 is the step. So now it's gonna start from the index position 2 and it's gonna take step size jump 2 indexes. It's gonna step 2 indexes and it's going to print until the index 7. So the index value 2 contains the character L, and the step it's going to take is 2 indexes, and the stop is 7, which is W. So this is also applicable for negative indexing, which is or reverse indexing. It's gonna print from start to end in the reverse manner. So it's gonna print from the last letter to the first letter in reverse.
Hey guys, welcome to the Python series. In today's video, we are going to talk about what are arithmetic operators. Arithmetic operators are used to perform mathematical operations like addition, subtraction, multiplication, etc. An arithmetic operator performs action on one or more operands. A set of such operators can be used within operations to perform a number of sequential calculations. Here, this is a table comprising about the operators and its description and syntax for the arithmetic operators. First, we have the plus, which plus symbol which depicts addition, adds two operands. The syntax is a plus b. Next we have the minus symbol which depicts subtraction, subtracts two operands. Syntax is a minus b. Next we have the star symbol which depicts multiplication, multiplies two operands, a star b. Next we have the forward slash which depicts division, divides the first operand with the second. The syntax is a forward slash b. Then we have forward double slash which depicts truncate division, which divides the first operand with the second, which elements all the decimal values after the decimal point, and the syntax is a double slash b. Next we have the percentage symbol which depicts modulus, which returns the remainder when first operand is divided with the second operand. Syntax is a percentage b. Then next we have the double star symbol which depicts the power or exponential, which returns the first raised to the power second, and the syntax is a double star b. Here a is the base value, b is the exponent. Next we have the negation, which usually is represented with the minus symbol, which returns the value opposite of the operand, or you can also use the not symbol to depict the negation, and the syntax here is nothing because it is an unary operand, it doesn't have a syntax. So let us do some examples on arithmetic operators. There are 8 arithmetic operators in Python. Let's look at each one by one. So first we have the negation operator. So let me assign a variable a with 6, and I'm going to say print a minus 6. So here minus symbol is used as negation symbol, and this is an unary operator because it contains a single operand. So it's going to give me the output as minus 6. So now let's look into the second operator, which is the addition, and it is represented by the plus symbol. So I'm going to assign a with 6, b as 4. So let me say print a plus b. So it's going to print the addition of these two values a and b, and the output is 10. So next we are going to look into the subtraction operator, which is represented with the minus symbol. Let me say a is 8, b is 3. So when I print a minus b, it's going to give me the subtraction of a minus b, which is 5. Next operator we're going to look into is multiplication operator, and it is represented by star symbol. And let me assign variable a with 6, b with 3, and I'm going to say print a star b. So here now it's giving me the multiplication of 6 into 3, which is 18. Next we are going to look into the division operator, which is represented with forward slash. Let us take a as 20, b as 4, and I'm gonna say print a forward slash b. It's going to give 20 divided by 4, which is 5. And suppose if you take a non-divisible number such as a is 10, and you're going to divide it with b is 4, which is not non-divisible, and I'm gonna say print a forward slash b. Is going to give me the answer in decimal value, which is 2.5. So if you want to remove the decimal value, and regardless whether it's a non-divisible integer, you want it to be an actual whole integer, and you would be using a method or an operator which is known as truncating division, which will eliminate the decimal value after the decimal point. So let me say a as 10 again, and b as 4. I'm gonna say print a, and truncating division is represented with double slash. So print a b, it's going to just giving you the integer, whole integer value, and it's eliminating all the decimal values after the decimal point. So now we're going to look into the modulus operator, which is represented with the percentage symbol, and it will give you the remainder of the two consecutive values. So I'm going to say a as 5, b to be 2, print a percentage b, which will give you the remainder, which is 1. So when you divide 5 with 2, you're going to get remainder as 1. So now let's look into the next operator, which is the exponential operator. Exponential operator is represented with the double star symbol. Let me say a is 6, b is 5, and let me say print a. Here a is the base value, and double star b here is the exponent. So when I print a star b, it's going to give 6 to the power of 5, which is 7776 or 7776. Hey guys, welcome to the Python series. In today's video, we are going to talk about membership operators and Boolean operators. So first, let's get into the definition of what is a membership operator. Membership operators are used to test if a sequence is presented in an object. Membership operator in Python can be defined as being an operator that is used to validate the membership of a value. This operator is used to test memberships in variables such as strings, integers, as well as tuple. Here is the table comprising about the membership operator. First we have the operator column, then description, then example. The first operator is the in operator, which describes that it returns true if a sequence with the specified value is present in the object. For example, x and y. Next operator is the not in operator, which describes returns true if a sequence with the specified value is not present in the object. For example, x not in y. The next operator we are going to look into is the Boolean operator. Boolean operators can also be termed as logical operators. Boolean operators are used to combine conditional statements. Boolean operators have the lowest priority in all operations in Python. First column we have the operator, the next column we have the description, and the next column we have the example. So first let's look into the first Boolean operator, AND operator. AND operator describes that it returns true if both statements are true. So here you can see in the example that x is less than 4, and you're using the AND operator between these two statements, x is less than 4 and x is less than 8, and if both the conditions are true, then here the output would be shown as true. The next operator is the OR operator. Returns true if either one of the statements is true. So if x is less than 4 or x is less than 2, if either one of the two statements is true, then the output would be shown as true. The next operator is the NOT operator. It reverses the result and returns false if the result is true. So here you can see that in this case NOT operator is used. So as you can see in the first case where we use the AND operator, where we got the output as true. So here if you use the NOT operator, the output would be shown as false. Let's start with some of the examples of membership operator. Membership operators contains two operators, in operator and not in operator. First let's look into what is an in operator. We have a number 3 in a set of elements in a list which is termed as 1, 2, 3, 4, 5, 6, 7 and 8. Now we check if 3 is actually present in the group of elements in such as this list. And now let's execute it. So here it is showing the output as true because 3 is exactly present in the particular list. Now let's try for an element which is not there in the list, such as 9. So let's type 9 in 1, 2, 3, 4, 5, 6, 7, 8. So here the output would be false because 9 is not there in this group of elements. So now let's check for the not in operator. So 3 not in 1, 2, 3, 4, 5, 6, 7, 8. So here it is showing the output as false because 3 is there in the list of elements. So the output would be false. So now let's check for an element which is not there in the group of elements. So let us type in 9 not in 1 2 3 4 5 6 7 8. So here you can see that the output is true because 9 is not exactly present in the group of elements. So this is all about the membership operators. Now let's see about what are Boolean operators. There are exactly 3 Boolean operators: and Boolean operator, or Boolean operator, and not Boolean operator. Let's take a number 6 less than 8, and we are going to use the AND operator, and 2 equal to 2. Now let's execute this. This condition is correct, so the output would be shown as true. This condition of Boolean operator AND will only be true if both the conditions are correct. So here you can see that 8 is can't be less than 6. So here the condition here is incorrect. So AND operator would not be applicable in this case, so the output would be false. So next is the OR operator. In case of OR operator, any one of the condition is true, then the answer or the output would be true. Here you can see that both the statements are correct. So this can also be applicable for OR operator. Now let's take a statement or two statements where one of the statement is incorrect and the other one is correct. So we'll take 8 greater than 9, or 4 equal to 4. Here you can see that 8 can't be greater than 9. This statement is incorrect, but the other statement 4 equal to 4 is correct. So hence the output we will get will be true. The third and the last operator in Boolean operators is the NOT operator. NOT operator is used to reverse the answer. Let me show you how. So here we can see that 7 is greater than 4. So the Boolean value would be true. So now let's try using the NOT operator. Here NOT just reverses the output you have got. So if you had got a true, now by using the NOT operator, the output would be shown as false. It's also applicable the other way. Let's check for 4 greater than 7. Here the condition is false. So let's check for not 4 greater than 7. So here the Boolean value will be true because it just reverses the output shown. So I hope you guys understood all the concepts in this particular video. I'll see you. Welcome to the Python series. In today's video, we are going to look about what are identity operators. So first, let's get to know what is an identity operator. Identity operators are used to compare the objects not if they're equal, but if they are the same object with the same memory location. Here we use the double equal to operator to check whether and compare whether the values of the two objects are the same or not. So whether the left operand is equal to the right operand. This is the table for the identity operator. First we have the operator, then the description and the example. The first operator is the is operator, and it describes that it returns true if both variables are the same object. For example, x is y. The next operator is the is not operator. It returns true if both the variables are not the same object. For example, x is not y. So now let us do some examples on identity operators. So first let's start with taking a variable x, and we're going to assign it with a list of elements, which is item 1 and item 2. Next we're going to take a variable y with the same set of elements, item 1 and item 2. Next, we're going to assign a variable z and check whether it's equal to x. Now let us print a statement saying that x is z by using the is identity operator. Here you get the boolean value to be true, and so that the memory allocated for the object x would be equal to the object z. So now let's try for print y is z. So in this case you can see that it is false because the memory allocated to y is not the same as the memory which is allocated to z. So when we check for print x is y, although the list of elements present in both the variables are the same, but here it's showing boolean false because the memory allocation would be different in this case. So when we check for x equal to y, in this case you can see that it is true because the elements which are present in both of these variables are the same. So now let's try for another example by taking x equal to 5, y equal to 5, and let us take the variable z to be equal to x. So now let's print saying that x is equal to y. So here it's showing the value to be true because in this case for all the set of statements the boolean value would be true. So you can see that for print x is z the value is true, and for print y is z the boolean value also would be true. So here in this case also the print x equal to y would be true for the statements x equal to 5. So now let us take the print statement for x is not y. Here you can see that for this set of statements x equal to 5, y equal to 5 and z equal to x, the boolean value for this set of statements would be false. So if we try for print y is not z, it would be false, and when we check for x is not z, it would be false. So now let's take a variable x which is equal to item 1 and item 2. Same goes with the variable y. And we're going to assign a variable z saying that it is equal to x. So now let's check this set of statements with the print is not operator by using is not operator. So let's print x is not z. So here in this case you'll get the output to be false because we are checking whether the left operand is not equal to the right operand. So in this case it is true, so hence the boolean value will be false. So next we're going to check for print y is not z. So here it is true because y is a different value when compared to z. So now for print x is not y, here it is true all because the memory allocated for variable x and y would be different, although both the elements which are there inside the list for variable x and y are the same. So now let's check for print x not equal to y by using the not equal to symbol. Here you're getting false because both the elements which are being assigned variable x and y are the same. I hope you guys understood all the concepts in this particular video. Guys, welcome to the Python series. In today's video we're going to look into what are relational operators. So relational operators compares the value. It either returns true or false according to the condition. Relational operators are binary operators because they need two operands to operate. So an expression which contains the relational operators is called relational expression because it checks and compares the two operands whether they're equal or greater than. This is the table for the relational operators. First we have the operator, then we have the description, then we have the example. The first operator is the equal to operator, which describes equal. So here in this example you can see that if x equal to y, then the boolean value would be true. The next we have the not equal to operator, which compares the left operand and the right operator. So hence here in this case x not equal to y, so here x and y are different values, so x and y are assigned with different values, so hence then you would get the output to be true. Now next we have the greater than operator, which checks if the left operand is greater than the right operand. The next we have the lesser than operator, which checks if the left operand is lesser than the right operand. The next operator is the less than or equal to operator, which checks whether the left operand is less than the right operand or it is equal to the right operand. The next we have the greater than equal to operator, which checks whether left operator is greater than the right operand and or whether it's equal to the right operand. Let's start with some of the examples for relational operators or alias comparison operators. So first let's take a variable a. I'll assign it with 5. Next a variable b with equal to 2. Then I'll print say that a is less than b. So here it is false because a is greater than b. So in this case the boolean output would be false. So instead if we print a greater than b, we would get the output to be true. So by using the less than or greater than operator, we can check whether the left operand is less than the right operand or whether the left operand is greater than great operand by using the greater than symbol. So now let's check for the operator which is the less than or equal to. So let's print saying that a is less than or equal to b. So here a is neither less than b or it is not even equal to b. So in this case a is not a is greater than b and a is also not equal to b. So in this case the boolean output would be false. So when we try for b less than or equal to a, here we would get as true because b is less than a. So here in this case the boolean output would be true. So now let us take another variable c which is equal to 5 and let's check it out for print a is less than or equal to c. So here you can see that a and c have the same values, so hence they're equal. And let's check for print b less than or equal to c. So here also it's true because b is less than c, so hence b2 is less than 5. So in this case the boolean output would be true. So now let's check out the greater than equal to operator. So let's check if a is greater than equal to b. So yeah, it's true because 5 is greater than 2, hence the output would be true. And check if b is greater than equal to a. So here we would get the output as false because 2 can't be greater than 5. So now by using the equal to operator, we can check whether the left operand is actually equal to the right operand or they have the same values. Now by checking a equal to c, we can see that a is assigned with number 5 and c also with 5, so hence both of them are equal, so the output would be true. Now by using the not equal to operator, we can check that the left operand is not the same as the right operand. So by using the not equal to, we can say that. So here we can see that a is 5 and b is 2, so hence they are not equal. So by using this statement we can get to know that print A not equal to B, and the boolean output would be returning to be true. Hello guys, welcome to the Python series. In today's video we are going to talk about what are bitwise operators. So first let's get to know what is a bitwise operator. Bitwise operators are used to perform bitwise calculations on integers. The integers are first converted into binary, which is represented in ones and zeros. Then the operations are performed bit by bit. Hence the name can be confirmed as bitwise operators. When the result is returned in decimal format, bitwise AND operator returns 1 if both the bits are 1, else the output would be 0. If either one of the bit is 0, then the total output would be 0. Here is a table comprising about all the bitwise operators. First we have the AND operator, sets each bit to 1 if both the bits are 1. If either one of the bit is 0, then the whole thing is 0. The next operator we have is the OR operator, sets each bit to 1 if one of the two bits is 1. If either one of the bit is 1, then it's fine, so the output will be given as 1. The next operator is XOR operator, sets each bit to 1 if only one of the two bits is 1. The next we have the NOT operator. It inverts all the bits. So for example, if your input is 1, so the output would be 0. So it's just the reverse of what you have given the input as. Next we have the zero fill left shift. Shift left by pushing zeros in from the right and let the leftmost bits fall off. So here it shifts the value to the left. So here when you're shifting all this thing, it shifts all the zeros and pushes off all the zeros and gives you the valid input. The next we have the signed right shift. Shift right by pushing copies of the leftmost bit in from the left. So it pushes off all the bits which are zeros from the left and only considers the values from the right. Into bitwise operators in Python, first we have to get to know how do we convert a given integer into binary format. So in order to do that, so why do we have to convert a given integer into binary? So binary computers are operated or stores data and perform calculations based on binary input, which is made up of zeros and ones. So in order to communicate with the computer, we have to convert any given integer and we have to communicate using binary. So first let us take any given integer. So let me take suppose I'll take an integer 49. So I have to convert this given integer into binary. So basically a given digit in binary is represented by a bit. So a byte makes up 8 bits. So let us consider those numbers. So we have 128, then 64, then 32, then 16, then 8, 4, 2 and 1. So here is the 8 digits which we can consider to be as 8 bits. So how do we come up with these numbers? So basically 1 is nothing but 2 power 0, 2 power 1, 2 power 2, 2 power 3, and this is 2 power 4, this is 2 power 5, 2 power 6, 2 power 7. So here we can see that these numbers, these powers of 2 can be given to get this numbers. So how do we come up with this integer 49? So let us consider those numbers which can be summed up and we to get 49. So let me take 32, then 16, then 1. So when we sum up these given numbers, it would give us 49. So it is 32 plus 16 plus 1. So when we add all this together, we would get 49. So which is 32 plus 16, 48, and plus 1, 49. So now let us consider all the numbers we have considered to be as 1. So we have considered 32, 16 and 1. So we'll take these as 1. So all others are zeros. So this is 0, 0, 0, 0. So this is how we come up with the binary format for a given integer. So the binary format for this given integer 49 is 0 0 1 1 0 0 0 1. So now we are going to do some examples on bitwise AND. First we have a variable a as 49. We have already found out the boolean um, format for the integer 49. So next we're going to take b as 5, and now we're going to use the a and b. So here we are seeing that the output is 1. So now we will find out how we got this output to be 1. So here you can see this is the boolean table for the bitwise AND operator. So first we have two inputs, and based on these inputs we are going to get the output. So first, when we have the input 1 to be 0 and input 2 0, the output would be 0. Input 1 0 and 1, and the output would be 0. So if either one of the inputs are 0, then the entire output would be retrieved to be 0. So here the in third case we have 1 and input to 0, so the output is 0. So the last case we can see that both the inputs are 1, so hence the output retrieved would be 1. So now when we consider the both the inputs we have found for to retrieve the integer 5, so let us write down the values for the given selected values. So here for 4 and 1, so these both are ones, rest all are taken as zeros. So this 0 0 0 and 0. So hence we got 0 0 0 0 0 0 1 0 1. So when you try to use the bitwise AND operator, so we are going to use the bitwise AND operator. So here both of the inputs are 1, so it is 1 0. So if either one of them is 0, so the entire output would be 0. So 0 0 0 0 and 0. So hence 1, which is also 2 power 0. So 2 power 0 is nothing but 1. So when we find the bitwise AND for 49 and 5, we would get the value 1. So previously we saw that when we took the bitwise AND of variable a and variable b, we got the output to be 1, which is 49, and 5, which is 1. And we have seen that in binary format that how we got the bitwise AND for these two variables. So next we are going to see the OR operator. So we're going to take in the same set of values for a and b. So we are going to try the OR operator for a and b. So here you can see that the value for a or b is 53. So now let's see that how did we retrieve 53, and let's look at the truth table for the OR operator. So here you can see this is the truth table for the OR operator. We have two inputs, input 1 and input 2, and the following output. So for input 0 and 0, we would get output as 0. So if either one of the inputs are 1, then the output we would get also will be equal to 1. So here in the second case we have input 1 0 and input 2 as 1. So the one input value is 1, so the output would be 1. So the third case we have input 1 as 1 and input 2 as 0, so the output retrieved would be 1. And the fourth case, input 1 is 1 and input 2 is 1 and the output is 1. So if both the inputs are 1, then also the output would be 1. So now let's look at how we get the OR operator. So first we have 49 and next we have 5. So now we have to find the OR of 49 and 5. So we know that the binary of 49 is 0 0 1 1 0001. So this is the binary format we found for integer 49. So 5 for 5 is 0 0 0 0 0 1 0 1. So when we find the OR of these two integers, so when both the inputs are 1, so it would be 1. Here both are 0, so it is 0. So here any one of the value is 1, then we will get 1. So it is 0 1 1 0 0. So when we want to find the value, which is 2 power 0 plus 2 power 2 plus 2 power 4 and 2 power 5, so it's nothing but 1 plus 4 plus 16 plus 32, which is which is 53. 1 plus 4 plus 16 plus 32 is 53. So hence we found out that when we find out the OR operator by using the OR operator for this variable integer 49 and the second integer 5, we would get the value to be 53. Previously we looked at bitwise OR operator. So we had first integer to be 49 and the second one to be 5. So we found out the bitwise OR for A 49 and B 5, which turned out to be 53. So now next operator we are going to look into is the bitwise XOR operator. So I'm going to take this same set of integers 49 and B as 5. So next we are gonna use the XOR operator A. So here you can see by using the XOR operator we are getting the output to be 52. So let's find out how did get this, and first let's look at the truth table of the XOR operator. So next let's look at the truth table for the XOR operator. So first we have the input 1, input 2 and the output. So for input 1 0, input 2 0, we have the respective output to be 0. So here in this case also, if both the inputs are 0 or both the inputs are 1, then the respective output would be 0. Other cases it is 1. So for second case, input 1 0, input 2 1, the output is 1. And here for input 1 1 and input 2 0, the output is 1. For the last case, when both the inputs are 1, the output is 0. Let's find out the binomial for XOR operator. So this is our 49 XOR 5. So we know that when both are zeros or 1, then the output would be 0. Other than that, for other cases it is 1. So both are 1, so it is 0. So 1. So it is 0. For this is 1. So sorry. So for this is 0 1 0 1 1 0 0. So it's nothing but 2 power 2 plus 2 power 4 plus 2 power 5, which is nothing but 4 plus 16 plus 32, which is nothing but 52. So here we have the final product of 49 XOR 5, which gives you 00110100. This is the binary expansion for the given product. So we get 2 square plus 2 power 4 plus 2 power 5, which is 4 plus 16 plus 32, which gives 52. So here you can see that the variable a, which is assigned with 49, and b with 5, when we have the XOR of a XOR b, we got the value to be 52. So hence, by using the bitwise XOR, we also found out like how we expanded 49 and found out the binary expansion of 49 and binary expansion of 5, and found out the product of these two integers, and then we got the output to be 52. So last time we looked at the XOR operator, where we took in the first variable a as 49 and b as 5, and we retrieved the output to be 52. So the next operator we will be looking at is the NOT operator. So a NOT operator uses unary operand, which contains only one operand. So basically when we have and when we have an input and we have an output. So here, if our input is 1, so the output will be just the reverse of what we have in the input, so it would be 0. So if the input is 0, then the output would be 1. So this is what we can find in the truth table of NOT. This is the truth table of the NOT operator. So how do we get that? So let's look at this. So if our a is 49, so we are just going to use the negation symbol. So here we are getting the output to be 50. We'll see that how did we get this minus 50. So hence, in order to do that, actually negation a can be written as minus a minus 1, which is nothing but minus 49 minus 1. So this, by doing this, we get our output as minus 50. So by doing this, using the NOT operator or using the negation symbol, we can find that negation of a, which is our input, is equal to minus of a minus 1, which is minus 49 minus 1, which is minus 50. This is how we retrieve the output for the NOT operator. So now how do we find out the binary form of minus 50? So how do we find the binary form of minus 50? So now to do that, let me first find the binary. So let's write down the binary for 50. So for 50, the binary can be written as 0 0 1 1 0 0 1 0. So first we find the negation of 49, which is 0 0 1 1 0 0 0 1. So now we'll just find the negation of this. So here 1 becomes 0, 0 becomes 1, 1 1 0 0 1 1. So here we are this is the complement of the binary form of 49, which is just the reverse of 14, just the reverse of 49 what we got. So now how do we find for minus 50? So in order to do that, we'll just take this number and find the complement of that. So basically we have 0 0 1 1 0 0 1 0, and when we find the complement it is 1 1 0 0 1 1 0 1. So this is the complement of 50. This is actually the binary form of plus 50, and by doing the complement we can find out the complement of minus 50. So now we are going to look at bitwise left shift operator. So first let us take an integer as equal to 15, and we are gonna say a is less than 3. So here a represents the value and 3 represents the number of ships we are going to take. So I'll be showing you how to do that manually. So here we are getting the output as 120. So what the required number we are taking is 15. So for the number 15, the binary form would be 0 0 0 0 1 1 1 1. So what we have to do here is we have to do the bitwise left shift, and we're gonna discard the first three elements, and rest all we're gonna just take these ones and we're gonna drop it here. So it's going to be 0 1 1 1 1 0 0. So hence when we so this is 2 power 3, 2 power 4, 2 power 5 and 2 power 6, so which is nothing but 64 plus 32 plus 16 plus 8, which is nothing but 120. So this is what we have got here. A less than 3. This is the bitwise left shift, where we are shifting 3 units to the left, and the output we are getting is 120. So here you can see that the output we retrieved is 120 by just shifting and just discarding the first three element and shifting these to the left, and just adding another set of zeros onto the end of this form. So this is about bitwise. Now we're going to take the same integer a is 15. We're going to take a as 15, and now we're going to operate for bitwise right shift, which is a greater than 3. Here you're getting the output to be 1. So let's look at how we should do and how to find out this manually. So let us take our number to be 15, and we know that 15 is 0 0 0 0 1 1 1, and now what we are going to do is we are discarding
the terms this outside, and we're just gonna take this and put it here. Yeah, so it's nothing but we're gonna put this to the right, which is 1 0 0 0 0 0 0 and 0, which is nothing but 2 power 0, which is 1. So hence we saw that by doing the bitwise right shift, we are going to shift all the bits which are there on the left to the right, and the last three digits or the bits on the right would be discarded, and the left ones would be shifted to the right. So as we saw here, for bitwise right shift greater than 3, we got the output 1. So hence by using manual method we confirm that we get this to be 1. So if we are finding it difficult to find out these manual methods and want a way just so that we can get directly, so we can use two built-in options operators which can directly give you the binary format of a given integer by saying that I want the binary of suppose I'll say 15. So here it will give me the binary form of the integer 15. So I can also convert this binary form back into the integer by using another built-in operator int and specifying the binary input. So by doing this, I can see that I'll retrieve back the integer what I have mentioned here. So these two built-in operators can be easily used to find out the binary form of a particular integer.
Hello guys, welcome to the Python series. In today's video we're going to talk about what are assignment operators. So first let's get to know what is an assignment operator. Assignment operators are used to assign values to variables. The most commonly used assignment operator is the equal to symbol. So the assignment operator can be termed as infix. These are special symbols which can carry out arithmetic, logical and even bitwise computations. So here is the table for assignment operator. First we have the operator, then we have the example. So we have the equal to symbol, which is the example for this is x equal to 5, which is same as x equal to 5. Next we have the operator plus equal to, example x plus equal to 1, which is same as x equal to x plus 1, minus equal to x minus equal to 1, which is same as x equal to x minus 1. Then we have star equal to, which is x star equal to 1, which is the same as x equal to x star 1. Slash equal to, here the example we have taken is x star slash equal to 1, which is the same as x equal to x slash 1. The next we have is the percentage equal to, the example we have taken is x percentage equal to 1, which is the same as x equal to x percentage 1. The next operator we have taken is slash slash 0, which is truncate division. Example x slash slash is equal to 1, which is same as x equal to x slash slash 1. Next is star star equal to, which is the power. So x star star equal to 1, which is same as x equal to x star star 1. Next binary and equal to, example x binary and equal to 1, x equal to x binary and 1. Next we have the or operator or dash or equal to, x or equal to 1, x equal to x or 1. Then next we have the XOR operator, XOR equal to, x XOR equal to 1, which is the same as x equal to x XOR 1. Next we have the binary left shift operator, so greater than equal to 1. The example is x greater than equal to 1, which is same as x equal to x greater than 1. We can also take the right shift, which is x less than equal to 1, the same as x equal to like x less than x equal to 1. And variable, let us say x, and we're gonna assign an integer 5 to it, and let us say print x. So here we can see that it's going to print you saying 5. So this is nothing but this can also be written as x equal to 5, which is the same. So next assignment operator we have is x equal to 49 and x plus or equal to 49, and we're gonna print x. So here we can see that it's gonna print, so this is nothing but it's the same as s equal to x plus 49, which is 49 plus 49, which gives you 98. Next we have x equal to 49, x minus equal to 49, and we're gonna say print x. So here this is nothing but x equal to x minus 49. So here you can see that this gives your output as 0 because 49 minus 49 is 0. Next we have x equal to 49 and x into equal to 49, and we are saying print x. Then let's say x equal to x into 49. So by doing this we can see that 49 into 49 gives you 2401. So the next assignment operator is x division 49, and when we print x, this is the same as x equal to x divided by 49. So we get 1.0, which is 49 divided by 49, which is 1. Next we have x 49 x percentage equal to 49, and we're going to say print x, and this is the same as x equal to x percentage 49. So here we can see that 0 because 49 is entirely divisible by 49, there is no remainder as such, so the output would be shown as 0. So next we have x49 x, so this is truncate division, so we say print x, and this is same as x equal to x truncate division 49. So here we, so now let us take x 49 and say x star star equal to 49, which is the power, and we're going to say print x, and we're going to comment saying that it's x into 49. So here we can see that we have found the power of 49, which is 49 to 49. Next we have x equal to 49 and x binary and equal to 49, and we are going to say print x, it's nothing but x equal to x and 49. So when we find out this, it turns out to be 49. So next we have x equal to 49, x or equal to 49, and we're gonna print x is nothing but x equal to x or 49.
So next we have x equal to 49, XOR equal to 49. So print x. This is the same as, so here we are getting 0. So next we have x equal to 15 and x left shift equal to 15, and we're gonna say print x, which is the same as x left shift 15. Now let's look at the right shift. We have x equal to 15, x right shift equal to 15, so print x. This is the same as x equal to x 15. Here you can see that this is the left shift is 491520. So this is all about the assignment operators. I hope you guys understood all the concepts in this particular video. I'll see you guys again in the next video.
Hello guys, welcome to the Python series. In today's video we are going to talk about what are if statement. So if statement is part of the control flow statements. So an if statement is written using the if keyword. The control flow statements here uses indentations or white spaces and colon. So in this case, in Python particularly, indentations are very much important. So when we don't provide indentations before the statement, then we find errors and we will not be able to get our desirable output. So the syntax for if statement here is a simple syntax is if expression statement else and in colon the next line indentation statements. So we often use this kind of statements when we want to execute a certain code and in a particular condition has been met. For example, suppose I have a flight at 12 o'clock. So if I go there in time, I'll be able to catch the flight. Else, I would be missing the flight. So in the same case, you can consider this if statement. So to control this logic, we use some keywords. So if, elif, else. So elif can be used when you have multiple scenarios or conditions. So that time elif statement comes into consideration. So as I mentioned earlier, indentation is very much crucial for Python than in comparison with any other programming language. So here is the syntax when you have multiple statements. So if expression colon the next line indentation statements, then followed by elif expression colon the next line we have indentation statements. So this elif statements varies because we have many more statements, so the elif statements keeps on adding up. So the last we have the else expression colon followed by the next line indentation and statements. Let's do some examples on if statements. So let's start with the simple syntax or simple if statement. So suppose if I have if 2 equal to 2, this is true, then I'll print saying that this statement is correct, else I'll print saying that this statement incorrect. So when I run this, here you can see if 2 is equal to 2 is true, so hence it will be printing this statement. Print statement is correct. So if I change this, to some other number 3. So now it will be printing the second part, which is the else part. Print the statement is incorrect. So let's go for a statement where we can. So now let's write a statement if elif else statement for multiple statement condition. So for example, if I take marks as input, enter your marks, then I would say if marks is greater than 90, I'll print A plus. Elif marks in between 90 and 80. Print A. Elif marks between 70 and 80. And 70. So BB. So when we have left marks between 50 and say print C plus, and if marks is 40 to 50, I'm going to say print C. And if 30, 35 to marks So when I write a simple statement like this, so I enter my marks, so it will be showing where does my marks lie in this particular set of statements. So this is how you do a statement containing elif statement. So I hope you guys understood if and else statement concept. I'll meet you again in the. Hello guys, welcome to the Python series. In today's video we're gonna talk about what are for loops. So first let's get to know what is a for loop or a for statement. A for loop is used for iterating over a sequence which which can be a list, a tuple, a dictionary, a set, or a string. So this is not like the keyword which is can be used in other programming languages, which is the for. It works like more like an iterator, yeah, which is found most in object-oriented programming languages. With the help of the for loop, we can execute a set of statements, one for each item in a list, tuple, set, string, etc. So here we can see the syntax for the for loop. It can be told as my iterable will be equal to the sequence. Sequence can be a list, a tuple, a dictionary, a set, or a string. Then next we have for item name in my iterable, then colon. The next line you have to provide an indentation. This indentation is applicable for all uh, um, the control loop statements, and then write the print item name. Also on for loop. So first, so let me take my list to be equal to 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10. So now I'll say for num in my list. So here the variable name can be anything. So here you can see that when I specify for num in my list and say print num, it will print all the numbers which is there available on my list. So let us try something else. If I change this num to some other, suppose I say hello world. So here it will print hello world 10 times instead of printing all the elements of my list. And if I can also change my num to var, doesn't matter, the result would be the same. So now let's write a program to check and print the even numbers of the in my list. Oh, so I forgot to specify a column here. Oh, so there's an indentation error. Oh, I forgot to mention. So here you can see that number is odd. The first number 1 is odd, then it will mention 2, then third is odd, fourth is even, so fifth is odd. Yeah, it will come in this manner. So let us take another program saying this, I would say my initial sum. Okay, before writing that I have to initialize it. So let me initialize my sum to be equal to 0. Yeah, now let us write my initial sum to be initial sum plus the num we have assigned here, and let us say print num. So here you can see that my sum is initialized, and it will just print. So it will just keep on adding 0 plus the num. If I want if I change, and if I just change this to some variable 10. Now we can use for loop for even strings, tuples, and even sets. So now let's try a for loop for a string. Let me say my string equal to, let us say, hello world. Yeah, and for letter in my string, so I'm gonna print each letter which is present in my string. So I'll say plain print letter. Sorry, I forgot to see, I forgot to mention the colon. So if you forget to mention the colon, it's a very big it will show you an error. So here you can see it will print all the letters of which are present in my string hello world. Next, let's try a for loop for a tuple. Let me say my tuple equal to 1 comma 2 comma 3. Then for each item in my tuple, I'm gonna print that item. So here you can see it will print out all the specific items which are present in my tuple. So I can also use a set. Let me say my set equal to 1 comma a comma 2 comma b. Yeah, so this is my set. So, and I'm gonna say for item, for element in set, print element. So yeah, I forgot to mention colon again. So here you can see that it will print out all the elements which are present in the particular set. So now let's try one for loop for a dictionary. So my dict equal to, let me say, k1 colon 1 and k2 colon 2 and wait, yeah, k3 colon 3. These are the items which are present in my dictionary. So now this is right for item in text, print item. Yeah, and yeah, I have to mention a colon here. So yeah, here you can see it will print each and every item in the particular dictionary. So now let us see how range function can be used in a for loop. So for example, for I in range 0 comma 10, I'll say print I. So here you can see it will print out all the numbers which are there in the range. So here it will print from the start to the n minus 1. If this is 0 comma n, so the numbers would be printed until n minus 1. It will not print until 10, it will print only until 9. So if you also want to include this also 10 in your output, then you should be incrementing this to 11. So then it will be printed from 0 to 10. So let's try out for a range. So now I'll be specifying this one 2 here. This 2 represents the step I'm going to take in between 0 to 11, step or the jump I'm going to take. So let us say print I. Oh, forgot to mention this. Okay, so here you can see that it took steps of 2 and it missed out 1, 3, 5, 7, and 9 in between, and it printed out all the other numbers, or you can say print out the even numbers in between this. So now I'll be using two values in for loop. So for example, for I in range, let's say 0 comma 5, and for j in range 0 comma 3, I'll say print I into j. So here it will be printing the print statement for I into j, which is lies in between I in range 0 to 5 and range 0 to 3. I hope you guys understood all the concepts in the particular video. I'll see you again in the next video. Thank you guys. Hello guys, welcome to the Python series. In today's video we are going to talk about what are while statement. Let's discuss what is a while statement. In Python, while loops is used to execute a block of statements repeatedly until a given condition is satisfied. And when the condition becomes false, the line immediately after the loop in the program is executed. While loop falls under the category of indefinite iteration. Indefinite iteration means that the number of times the loop is executed isn't specified explicitly in advance. Here is a syntax you can see for while statement, which is while expression. And next you're going to start with the statement and else with the following other statement. Now let's look into what are break, continue and pass statements. So the following statements can be applied when under these conditions. We can use break, continue and pass statements in our loops to add functionality for various areas. For example, we can use break when we want to exit out of the loop or exit out of the current closest enclosing loop. Then we are going to use the break statement, and continue statement is used when we go to the top of the closest enclosing loop. Now we use the pass statement. Pass statement just acts as a filler element, just does nothing at all. It just allows the following loop to iterate and doesn't disturb the following enclosing loop. So now let's do some examples on the while loop. First we have I equal to 0, then while I less than 10, print so we'll be using string formatting here, and let's say I equal to I plus 1. So when we execute this, let me try restarting the kernel. So uh, so yeah, here you can see that the current value of I is 0, 1, 2, 3, and it'll print until the number 9. So here in this case, when you go to the number 10, 10 will not be actually less than 10, it will be equal to 10. So hence the condition would be false. So the iteration would stop there and it would print until the previous value, which is number 9. So let us take another example saying I is 0 while I is less than 10. So here so you can either use I is equal to I plus 1 or I plus equal to 1. So both of them would be the same. The result of both of these statements are the same. So you can either use this or you can use this. So in this case, I'll be using I plus equal to 1. And let's include an else statement and saying that if it exits the while loop, it should print I is not less than 10. So yeah. So when you're gonna go print this, it'll print until the number 9. When it goes to the 10th integer, when I becomes 10, it would print this because the condition here is false. 10 can't be less than 10, so it'll go to the else statement and it'll print this one out. So let's just try some comparison, and let us say I is 0 and j is 5, and while I is less than j, we'll print I and j, and let's increment this plus 1 equal to, and or else print exited while loop. So here in this case, when we print this, it's gonna print the values of I and j consecutively, and when I becomes equal to 5, it will exit the while loop and it will print out this statement, which is part of the else statement. So here you can see that the it has exited after when I is 5. So now let's look into some of the examples which can be implemented using the break, continue, and pass statement. We have I equal to 0 while I is less than 10. If I is equal to 5, you're gonna now break and print I, and I plus equal to 1. Yeah. So here you can see that when I executed the statement, it would break immediately. It reaches 5, and it will stop until the integer number 4. So it will print until 0, 1, 2, 3, 4, and it will break after that. Now let's see how we are going to implement the continue state. So here you can see that when I executed this continue statement, it would print until the value 4, and it will, if I is equal to 5, it will not execute this number 5, and it will continue. It will go on to the next following integers, which is 6, 7, 8, 9, 10, and it will print until I is less than 10 or equal to 10. This is about continue. Here we use the pass command to this set of statements, and we have executed it, and here you can see that it just does nothing at all. It just passes it out and lets you to execute and iterate throughout the command. So here if you have any syntax error mentioned, which like a typo error or something, it just lets you to pass the following statement, and it prints you out and it iterates the following. So now we'll be trying try and accept. So basically what is that? When we try and say if name is greater than fur, print hello world. Yeah. Or if accept, print there is something wrong in your code, and please check again. So when we are trying to execute this, So here you can see that when you're trying to execute this, it says that there is something wrong in your code, and first it tries and executes the first set of statements, which is this: if name is greater than 4, print hello world. And if it finds any fault, it directly goes to the except and it will print out this statement. So here you can see here name is not yet defined. Name is not at all defined. So it just can't iterate. So here this is an error here. So it directly goes to the except and it will print out this command. So here you can see that while trying this try and accept, it will try and check whether there's an error in this set of statements. And if there's an error which shows up, it directly goes to the accept command and it prints you out this command. So if either, regardless whether you have error or not, when you finally want the result to be printed, you're gonna use the command statement known as finally and say print the try except is finished now. So regardless whether you have got an error in here or don't have an error there, it will just print you out this statement right away. So here you can see that it prints you out the statement the try except is finished now, regardless whether there is an error here or not. And here yes, there's an error there, so that name is not is an undefined statement here. So it goes to the except and prints you out this, and along with that it'll also print you this statement, because regardless whatever the set of statements above are considered, it'll print you the statement. Hey guys, welcome to the Python series. In today's video we are going to talk about what are functions. So first let's get to know what is a function. Functions allows us to create statements that can be very easily executable many times without needing to constantly rewrite the entire block of code. So creating a function requires a very specific syntax like and structure, like such as indentation, etc. Data can be passed onto a function, in other words also known as parameters, and function runs the following set of statements when it is called. So here you can see this is a function which is often termed as def. The def keyword, you can use a define functions to provide the required functionality. So this function blocks begins with the keyword def followed by the function name and parentheses. The statement return followed by the expression exits a function, optionally passing back an expression to the caller. In the sense, return allows us to assign the output of the function to a new variable. So return keyword sends back the result of the following function and allows us to assign the particular output to a new variable. This is the syntax for the def function, where you def name of the function parentheses, and next line you have the doc string. Doc strings represented with triple quotes and explains what exactly the function does. And the next line followed by statements. And to call a function, you just have to specify the name of the function, which is represented after the def keyword. So let's do some examples on functions. First, we have the def keyword followed by the function name. So here in the case, we'll say hello world. And parentheses. So we are going to say print hello world. So we will not get the output because we have created a function, but we haven't called the function yet. So in order to call the function, we just have to specify the name of the function. Here in this case, hello world. So just specify the name of the function. So yeah, here you can see that the function main hello world has been called. So let us do another type. So when we say def greeting and we're gonna mention the name, and let us say print hi there plus name plus. So when we're gonna call greeting, and let us say our greeting the person named Ram. So here you can see that it will mention the hi there Ram. So we can mention a space over here. Yeah. So here you can see it greets saying that hi there Ram. So let us try one more example. For example, let's define a function known as animal and give it name and print red. So by in this case you would have already understood which animal it is. Let's just try it out. So here you can see that when you mention dog, it gives you a message saying that dog is barking here. So that is what def keyword does. So now next let's write a function so that we can add two numbers. So let us create def saying that add function. So now let's write a function to add two variables, and we have num1 comma num2. These are two variables, and we are going to use the return function, and let us say num1 plus num2, and the result is a new variable where it's going to add it's going to carry the output of the particular return function. Result is the variable which is going to have the output of the return function. So have the add function, and we're going to assign num1 as 1 and num2 as 2, and I'm going to print result. Yeah. So here you can see that the output we got is 3. So 1 plus 2 is 3. So this is a simple function where you can add two integers. You can also do subtraction. You just have to have a minus sign here. So here you can get the result that 1 minus 2 is minus 1. So you can also write a function for multiplication. Just change it to mult and say that, and just change it to asterisk, and we'll give it something else like suppose 3. And when we try to yeah, we have to change this also. So now let's try. Here you can see that it gives you the multiplication of these two numbers, which is 3 into 2 is 6. So this is all about multiplication in so now what we do is we'll just change the second integer to a string. So suppose we'll say Ram. So let's see what will be the output for this. So what it does actually, it just prints out this string two times. So actually expected a integer to be here, but you have actually inputted a string here. So what it does here, it doesn't actually use a multiplication symbol. It just gives you two numbers of this variable string. So it just adds it up, and it, it might not give you error because it just you have input a string here, so it just gives you the two times of the. So now let's try another example. Suppose I have a function add1. I'm gonna assign a variable a to it, and let's say b equal to a plus 1. Yeah, and I'm gonna say print a comma, so plus 1 will equals to, and let's say b. So what we're going to do is we're going to return b, and let's see, and let's call a function add1, and we're gonna give in say 4. So here you can see that 4 plus 1 equals to 5. This will be your output, because what you're trying to do is you're assigning a variable b as the output function, a very new variable, and the result, whatever uh, the written value stores, is b, and a plus 1 is just variable a plus 1, which will be equal to b, which is 5. So 4 plus 1 will be equal to 5. We can also implement multiplication here. Just use mult here and convert it to asterisk, and let's say 2, and let's say multiplied by, so 2 equals, okay, yeah, let's try this out, and we'll just change this to what. Here you can see that 4 multiplied by 2 equals 8. So in this case, this is how you do the common elementary addition multiplication in functions. Hello guys, welcome to the Python series. In today's video, we are going to look into what are star args or asterisk args, which can also be termed as non-keyword arguments. The special syntax star args or asterisk args in function definitions in Python is used to pass a variable number of arguments to a function. It is used to pass a non-keyword variable length argument list. Here, in this case, a single star or a single asterisk symbol before the argument name is represented to pass a non-keyworded argument. So the syntax to use the symbol star to take in a variable number of arguments by convention is often used with the word args. Here, it is not mandatory that you use the word args. It can also be any other word such as an integer, number, or animal, dog, anything. It can put in any name as you wish, but you have to make sure that the asterisk symbol is present before the argument name. So here, this star or the asterisk symbol allows you to do is to take in more number of arguments than the number of restricted formal arguments that you previously had defined. So for example, we want to make a multiply function that takes any number of arguments and be able to multiply them all together. It can be done using the star args, where you can take a set of arguments and use the multiply function to get the multiplication of those set of arguments. So by using this, the star or the asterisk symbol, the variable that we associate with the asterisk symbol becomes an iterable, meaning you can do things like iterate over it, run some higher order functions such as finding the mapping of a given set of arguments, and also the filter of a set of arguments, and also can find the square of a given argument, or squares of a given integer. First we have def, let's say a comma b. Yeah, so So returns 12% of the sum of A and B. So we'll say return sum A comma B 0.12. So when I call in my function, yeah, so just have to specify the value. So 20 comma 50. So here you can see that it will return the 12% of the sum 20 plus 50 is 70, and 12% of 70 will give you 8.4. So here in this case A is my first argument and B is my second argument. So in a case where we need more than two arguments, so find the sum and return the 12% of more than two arguments. So in this case, let us take A comma B comma C equal to 0, and let's say return sum A comma B comma C um, into 0.12. So here in this case, when we pass in our given arguments such as 20 comma 50 comma 70, so here you can see that it'll pass you, it'll give you the 12% of the sum of 20 plus 50 plus 70 and gives you 12% of it. So in a case when we have we can also add in one more, and let us say 90, and yeah, and try this. So here it will give you 27.75. You can add one more 0 and E, yeah, and let us say 160. Yes. So here you can see that my function takes from only 2 to 4 positional arguments, but 5 are given. So here the formal restriction for the number of arguments for my func is just 4, 2 to 4. So we can't take more than that. So in this case, what shall we do? So in this case, we are going to be using the star qual, star args, or the star asterisk symbol before the given argument. So let us say my func, and let's say star args, and let us return sum of star arcs into 0.12. Yeah. So when I call my function, I can give as many as arguments I like. So I'll be giving so what it does, yeah. So I should erase this here, and yeah. So here you can see it took all these arguments and it took the sum of these arguments and then gave the 12% of the set of arguments, and here you can see the output is 180. So by using the star asterisk symbol before the given argument, you can take in as much as arguments as you like. So here you can take more than 10, 20, like how much ever you want. So So it doesn't really matter that this should be arg, that it should be named args. It can also be like number, star number, and so number or numbers. So here you can take it as this, and you can, yeah, it doesn't matter whether you should name it as args itself. You can also name it as any name you want it to be. Hello guys, welcome to the Python series. In today's video, we are going to look into what are quarks or double star quarks, which can also be termed as keyword arguments. The special syntax double star quarks in function definitions in Python is used to pass a keyworded variable length argument list. Earlier, when you saw in single star args, where a single star or a single asterisk symbol is used to pass a non-keyworded argument, in this case, when you use a double star before the argument name, it will be used to pass a keyworded argument. So we use a name quarks with the double star, and a keyword argument is where you provide a name to the variable as you pass it into the function. One can think of the quarks as being a dictionary that maps each keyword to the value that we pass along it. So in this case, quarks, we are using a keyword value pair to represent inside a dictionary, whereas in earlier case when we saw in star args, we used an argument to be passed into a tuple or a list. So that is why when we are using a dictionary in quarks, we iterate over the quarks. There doesn't seem to be any order in which they are printed out. So now let's try some examples on quarks argument. So suppose I have my function, and let's name it as star quarks, and if so item in quarks so we will be using the string formatting here. So no. So here you can see that I use a dot format method, and I mentioned quarks and the particular item to be evaluated through my dictionary. So I to the item. So now let me call my function. I'll say my function, and item would be ball, and the item 2 would be pen. So what it does, it gives me out my item, which is the ball, from the given set of this thing. So when I do not have anything, so if I just name it as 1 instead of item, so it just prints out this else part of the else statement, print I do not require that item. So you can also use the combination of args and quarks in a particular function. So let me show you how. So define my so I'll be using both the args and quarks. So args comma star quarks. So let us print args and print quarks. So So, so function 0, comma quarks, and let it be item. Yeah, when I'm executing this, yeah, column there, yeah. So, okay. Yeah. So now I'll just call my function, and I'll give in my arguments. So it's going to be 1 comma 3 comma 4, and um, let's say fruit equal to mango, and here instead of, and the item will be ball. So what it does is basically print out the following key value pair and the args which is inside a tuple. Will print out all the arguments in a tuple, and quarks will print the key value pair in a dictionary, and the following statement would be printed: I would want one ball. So here the index value 0 for arg is 1, so it would print 1, and for quarks it is the item which is the ball, so it would print I would want one ball. So now let's try adding in more elements into this. So for example, I would like to have food, and food will be equal to pasta, and I'll also be adding my color. Color would be blue. So when I try executing this out, so here you can see that it will print all the arguments for star args in the form of a tuple enclosed in a tuple, and the double star quarks, whichever has been done using the arguments, would be in the form of a keyword value pair. This is a keyword value pair, these things. So this would be printed in a dictionary, as you can see here, and my following output for the index 0, which is 1, and the food I have mentioned is pasta here, so it would give me the output saying that I would want one pasta. So I hope you guys understood all the concepts in this video. I'll see you again in the next video. Hello guys, welcome to the Python series. In today's video, we're going to talk about what are map function and filter function. First, let's look into what is a map function. The map function iterates through all items in the given iterable and executes the function we passed as an argument on each of them. So we can pass as many iterable objects as we want after passing the function we want to use. So here the map function returns the map object type, which is an iterable, and we could have printed the results like this as well. If you'd like the map function to return a list instead, you can just cast it when calling the function. Here you can use the traditional for loop to get the following output, or else you can use a list instead to get the output. So here is the syntax for the map function: map followed by parentheses function comma iterables. So next we are going to look into what is a filter function. So filter function is similar to map function. Filter takes a function object and an iterable and creates a new list. Here also you can use the traditional method by using a for loop to get the following output, else you can use the written list to get the output. As the name suggests, filter forms a new list that contains only elements that satisfy a certain condition. The function we passed returns a boolean value, which is true in this case. So here is the syntax for the filter function. Filter followed by parentheses, function, comma, iterables. So now let's do some examples on map and filter function. So first we have the map function. So just by entering shift and tab, you can get to know the descriptions of the map function. Here you can see in it, the initial syntax for map function is map self and followed by args and quarks. So this is the following syntax for the map function: map function and comma iterables. This is the map object. So here is a short description about what the map does. So for example, let's define function saying square. So we're gonna return num, and we're gonna find the square of this particular number. So when we try to assign a variable to a list, so I can use a for loop for finding the square of these numbers, these set of numbers, but I think it would take a lot of time. So instead I can use the map function to find out the square much easier. So I'll just say map square nums. So here you can see that the map is an object where it is stored at a memory location which is 0x219E1C8CD5D30. So in order to implement this map function, we'll just start with the for loop for item in So here you can see it will give you the square of the following integers. So square of 1, 1, square of 2, 4, square of 3, 9, square of 4, 16, and square of 5, 25. So instead of doing this, you can use an alternative method by getting a list of all the squares, saying list map, and so by doing this, it will give you a list of all the squares of the particular integers. So you can either use this for loop, or you can also use a list to find the squares of the following integers. So let's try another example, saying let us define a function known as splicer, and let's given our string. So we have to find we're going to given certain strings, and we're going to find the whether the given word or a string is even or not. So in order to check that, I will use the alien function and say my string, so percentile 2 is equal to 0. So then I'm going to return saying that it's even. Oh, sorry. Else I'll say return my string at index 0. So now I'm going to iterate this. So I'm going to give in the names. Let us say the names are Ram, Prakash, and Suresh. So these are the names, and let's find a list to get placer and my string and names. So now you can see that Ram has three letters here, so it would give you the first letter of the particular string, and Prakash is also an odd containing 7 letters, so it would give you the first letter of the particular string. Here Suresh is an even lettered string or name which contains 6 letters, so it would give you the output as even. So now let's try the same methodology for an number. Let's define to so we're gonna iterate this, and my numbers are gonna be equal to 1, 2, 3, 4, 5, 6. So these are my set of numbers. Now, I want only the even numbers from this particular list. So instead of trying to map, I can also use the function filter, where I can filter out based on the function, and let's say filter check even my nums. So here you can see it will say the filter function is stored at the memory location of 0x21 9E1DCT700, similar to the map function. Now we'll just use a list and say filter and mention the following arguments. So here you can see it'll filter out the even set of numbers from the particular list, and it'll show you in the output. So we can also use a for loop instead of a list, just by saying for and in filter and say check comma my. So you can either use this, and let's say print n. So by doing this, it will give you the set of even numbers in the particular list. Hello guys, welcome to the Python series. In today's video, we're going to do a very interesting exercise where we're going to create a tic-tac-toe game to create a fully interactive game using the Python program. So in order to start off for this project, we are going to code along with a few exercises in order for you to understand how the steps can be implemented to get the final tic-tac-toe game, or we're going to implement those stuff we have learned before in the following videos. So before we start off, these steps should be taken into consideration. First, grab user input. Second, manipulate a variable based on input. And third, return back adjusted variable based on the input or the information acquired from the user. So most programs that are interactive work on this very simple idea. First, display something visual to the user so that it looks more appealing or more entertaining to the user to go along the process. So second, let the user update through an interaction. So we're going to have a little communication between the user so that the information processed or the game could be much entertaining. So third, update variables in the program. So based on the information acquired from the user, we're going to update those variables in order to retrieve the final updated visual and display it. So let's start with the logic which we require, the initial steps we need to solve tic-tac-toe game. So let us say I have a list 2 comma 3, and say I'm gonna print it again and again 3 times. So instead of I'm printing print statement 3 times. So instead of calling this 3 times, what can I do is let me create a function so that the first step we have to do is display something visual to the user. So in order to do that, so let us create a function display. So let us take this row 1, row 2, and row 3. So row 1, row 2, and row 3. So these are the parameters I'm passing through, and let us print each of them. So right, so now let us name an example row, so that that will be holding the value 1 comma 2 comma 3, and let us say display, then you're gonna try to pass this as a parameter 3 times. Yeah. Oh, sorry. So here I have to mention row 2 and row 3. Yeah. Now, yeah, then pass this, then pass this. So here you can see that instead of calling this in such a way, I can do this in a simpler way just by naming a function display and mentioning row 1, row 2, row 3. So I'm gonna hold row 1 with let us say yeah, so colon, and row 2 with similar set like, and row 3. Yeah, so now let us display row 1, row 2, and row 3. So here you can see it's going to display in such a form, and I'll just replace one of the I- I'll just replace one of these terms into, let us say, row 2, and the first index I'm gonna name it as, let us say, x. So after doing this, and let us now display row 1 comma row 2 comma row 3. So here you can see that in the place of this there's an x which has been displayed. So we can also, for row 1 and 0, let us say x, and row 3 2, and let us say this is also x. So now when we display row 1 comma row 2 comma row 3. So here you can see that there's x's in this, this and this. So we can use this for allocation of the positions, like x in one position and o's in one more. You can also use o. Suppose there's an o over here, and we try to display that. So here you can see there's an over in this place. So now we can using this input function, we are going to, for better understanding of this allocation of x and o's. So now we'll use an input function. Let us say our input function is the position index, and we are going to ask the user to input his which position he wants. So yeah, so I'll say I want my position to be 2. So now when I check the type of my position, so it's showing it's a string here. So how do I convert this? So by using this input, it's going to convert that string into whichever data type I want it to be. So here, by taking the input function, I'm converting this string function into an integer here. So I'm inputting an integer. So it's going to take this and it's going to convert it into int data type. So to interact with the user, we need to convert it into the other data type. To retrieve the output, we are going to take a result saying that enter a number. We're gonna ask the user to enter a number. So let us say we take it as 3. So here you can see that by doing this, it although this is a string, input function helps us in converting into a integer type. So in order to give a choice to the user regarding which he has to choose, let us create another function saying user choice, and so this choice we are going to ask the user to enter a number, any number between so we're asking the user to enter any number between 0 to 10, and we're gonna return the choice which is there in the form of integer. So when we call the function, so you can see the type is main. When we call the function and ask it to enter a number, we are going to enter number 9, and it's going to retrieve back that integer. So this int allows us to convert into that data type. Now we'll allow the user to check whether his choice is correct or wrong. So I'll say choice and give it with the wrong, and I'm going to include a while statement. Choice is digit. This will check whether the value is true or false. So So I'm gonna say choice, and after this I'm gonna include an if statement. So if choice dot is digit will be equal to false, then we're gonna print saying that sorry, that is not a valid digit. Please try again. So this will be our message. So yeah, so let's print this. So let us say I'll enter 9 instead of 9. So I get this message saying that say, so let me try it out again. So I say 9. So here it shows that what I've entered is wrong. So I have to try it again. Now suppose I create a result saying that result is wrong value, and so acceptable values would be from 0, 1 and sorry 2. So we're going to check whether the result is in that acceptable values by using the in. So here it will show that it is false. So let us apply this in the saying that choice is wrong, and let us give our acceptable range to be 0, 1, 2, and I'm gonna assign another variable saying that so this will be the same. So if it is false, it's going to print this. So now let's check out this. Okay, yeah, let's try it out. So now let us enter a number 9. Sorry, that's an invalid entry. please try again. So now let us try it out with 9. So it has entered 9. So now we can see that we have done with the within range equal to false, and we're going to check. So this we are using if statement. This for checking whether the digit is within the range or not. So this is for the digit seg. So have to check whether the number is within the range or not. So now we're gonna go for range check. So here we're gonna write an if statement saying that choice in digit equal to true. So we have to make sure that it's within the range. So I'm mentioning true over here. So if int choice, so if int choice is, so if is in the acceptable range, so we can say that the within range will be true. Or else within range will be false. So it will not be within the range. So we'll give it as false. And we're going to print a statement saying that sorry, the number you have entered is out of range. So we're going to give this as the input, and so now let us run this. Okay. Yeah. So when we run this, okay. Oh, yeah. Now we're going to run this code and let us call our function user choice. So now let us run this thing. It's going to show that it's 2 and it's not a valid digit, or please try again, sorry, the number you have entered is out of range. So now let us try the correct number, and you can see it's taking all these outputs. So if you type in 2, it will check that yeah, it is in acceptable range, and it will print out that. So now let us name a function for displaying the game list. So a game list will be within 0, 1, 2. So we are going to define a function saying that display game, and the parameter we're going to pass through this is the game list, and we're going to print here is the current list. Yeah, and then we're going to print the game list. So when we display game list, so here you can see that it says that here is a current list 0, 1 and 2. So now we have to create a function which is used to determine the positional choice. So we are going to create a function to determine the position choice. So say position choice, and so initially we're gonna give it as wrong, and while choice is not in, so it should not be in the particular set of, and we're gonna print first we're going to give a choice and to the user and saying input pick a position. So that position is going to be in 0, 1, 2, 0, 1 and 2. So we're going to create an if statement if choice is not in so we'll print invalid choice, please try again. And when we do that and when we return int choice, yeah, so now let's try to print. Yeah, now let us call a function position choice. So let us pick a position, let us say 4. So it will say that sorry, invalid choice, please try again. So now let us say 1, 2. So it's going to pick the number 2. Replacement position choice for the user for better gameplay experience. So let us define a function replacement choice, and we have to know the game list as well as the position choice, the previous first position choice, the first option which the user has opted. And next we're gonna take in an input saying that type a string to place at position. And we're gonna assign a variable which will be holding this input, game list position will be holding the input of the particular placement. We're gonna retrieve back game list. So when we call in replacement choice game list, and here we're going to enter a position to be 1 instead of 2. So game list is not defined. So here's the mistake here. So now let us say so I'm gonna place a string instead of 1 in the place of position. So in order to keep on playing, we should also add a game on choice. Let's define game on choice. So game on choice, and take the initial considerations, and so choice will be wrong. So while this choice is not in, so you're allowing the user whether to choose whether the choice is yes or no. And we're going to input saying that pick a position 0, 1, 2, and every statement saying that if the choice is not in the particular set of which is 0, 1, 2, we're going to print a statement saying that sorry, the choice which you have chosen is invalid. The choice and next we're gonna return choice. Okay, and indentation. So yeah, so now let's call game on choice. So let us pick a position. So let us say we pick a position 1, and we'll say why. It will show that the game chosen is invalid. So let's try again. So let me choose 1, let me choose 2, let me choose 0, and let me choose 4. So it will show that the choice you have chosen is invalid. So we are asking the user whether he wants to keep playing or not. So the choice is input keep playing or not. So we input y, yes or no. So instead of this, let's keep it as this. And if choice is not n, y and n, so let's erase this part. It's gonna print a message saying that sorry, I don't understand, please choose either y or n. So we'll enter this and give a choice. If choice is equal to y, so equal to y, we'll return true, else return false. Yeah, so we're gonna run this. Input yeah, so yeah, we're gonna run this and check. So keep playing or not, we'll say n. Yeah, so now let's run this and check. So here you can see when we print 9n, it's saying it's false. So now let us keep in the continuity of the game. Let us create the display position of the particular game. So the while game is on, display the game, which is nothing but the game list. Yes, and position of the thing will be position choice. Position choice. So now what you're going to do is we are going to take in the game list and we use that as the replacement choice, so that we can have another option if we are not liking the present choice which we have already. So that will contain the game list and also the previous position which we have entered. So the game list and the previous position. The next we're going to display the game. So game on will be equal to game on choice. So yeah, we're gonna print, so we're gonna pick a position, say I'll print an invalid position, say 2. So it will say that it's an invalid entry. So let me try again. So I'll pick a position 2 and the string at position is 0. So keep playing yes. So I'll pick 2 now. No, I'll pick 1. So I'll say run. So at 1 I'll say run and keep playing no. So yeah, it is stopped running now. So here is the updated game list you would be finding after you've created this. So here you can see that when I first it asked me here's the current list and it showed the list 0, 1, comma 2, and then it asked me to pick a position from 0, 1 and 2. So I picked up the position 2. So then it asked type a string to place at position. So I just placed 0 as a string and placed it in that position, and it asked me whether I wanted to keep playing or not. Then I pressed Y, so yes. So again it went back to the current list, updated the current list again and gave me back the present current list which has got updated. This is 0, 1 comma string 0. So it asked me to pick a position. So I picked up the position 1. So then it asked me to type a string to place that position. So then I just typed a string called run. So then it showed me the present current list which has been updated, which is 0, run and 0. So it asked me to whether I wanted to keep playing or not. So then I typed in n. So that means I didn't want to play again. So it stopped the loop there itself. We are going to make a small creative program in order to start with you the tic-tac-toe game. So first we'll start it step by step so that you can clearly understand how to create a tic-tac-toe game in an easier way. So yeah, let's start with it. So first step, we have to write a function that can print out a board, like with all the like 1, 2, 3, 4 until the number 9. So like a number pad, we have to create a board where we can input our X and O in that board, like a 3 by 3 matrix representation. So let's start with. So first, let's start with Russell with image board plus 7, and we're going to add a dash. So we'll just copy this line. So we're just going to copy only this line, and let's just print it out 3 times, and we'll just change it this to 4 and this 5, this is 6, and let this be 1, 2, and 3. So in between these, we're going to print, let's say, the dashes. So print the dashes. So it's only required between these four, and the last line we just do not have it. So let's just and now we're gonna create a list which contains all the elements of a board. So respectively, like for the ash, it's in ash format, and we have the X and O's. Yeah, we're done with the board. Now what you have to do is we're going to display the board,
and let's just type in display board, and it will show you all the elements of the board. So here you can see that this is the element, so let's just delete these. So these are not required in case. They're not required. So, yeah. So let's run this, and let's run this, and let's run it again, and let's reduce these also. Reduce it by 2. That's fine, I guess. And let's run it again. Okay, let's remove one more so that, yeah, let's remove one more. And let's check it again. Yeah, it looks fine now. So the next step is we have to write a function which can take the player input. Like in the sense, when a person is choosing, there should be a marker which chooses whether you want to represent X or you want to represent O. So we have to make a function which will be assigned with a marker which will be assigned to the particular X, respective X or respective O. So let's just define a function known as player input, and so marker can either choose X or can either choose Y. Inputting a function, I would say, so we are going to give the user to input whichever he wants, whether he wants to choose X or O, and let's just give him the option, and let's take in upper. So this dot upper is used whether by mistake if the user enters a small letter X or small letter O, so that would be a mistake. So here we are using upper, so automatically it validates into uppercase letters, so it would be easier. And now we're going to use an if statement. So if the marker by chance chooses X, so we're going to return sorry yeah. So we're going to return saying that we're going to print X comma O, and if else it will return the other way, which is O X. So this would be the so now we're gonna just say player input and run this, and now the user can enter whichever, if he wants to choose X, he will be free to choose X, or if he wants to choose O, he's also free to choose O. So yeah, in case you enter a small letter, it will automatically be taken as O, because we are used the upper method over here.
So now we'll write a function that takes in the board list. So and object and mark takes a marker X and O. So it can take from the desired positions which are indexed from 1 to 9 according to the number pad. So according to that we are going to place the marker in such a position. So let's define a function for place marker.
So let's run this and we'll just place the marker to be board, comma, and we're going to take it as O, the marker to be O, and the position to be 3. So when we display the board, so here it will show that here you can see that position 3 it has changed to O. So here it was X, so here you can see that it's changed to O. That's what we do with this thing. And now we are going to write a function that takes in a board and check if that marker has 1 or not. So if it's aligned, so x are aligned in the first row, so X wins. So we are checking, we are taking a marker to check whether the marker has 1 or not, respective marker, whether X or O. So let's define a function to check whether he has 1 or not. So let's take it as win check, and we check the board and marker. So if the board 7 equal to marker, or and board 8 equal to marker, and board 9 equal to marker, or so we're gonna print this. So yeah, now let's just check, and now we're gonna return to, so we're gonna return if the particular marker has 1, or else we are gonna return false. So we're gonna run this and let's check. So let's check whether board O has 1 or not. So false. So here it's showing that board O has 1. So these are all the combination by through which you can win, like across row 1, across row 2, across row 3, diagonally in this position, diagonally in that position. So these are the respective uh, combination by which a marker X or O can win. So now we have to write a function which gives a random this thing, random model, like 0 to 1, like random integer from 0 to 1, and it will decide the player based on that number, like flipping a coin. When you get heads or tails, if you win the toss, if you get heads, you choose whatever you can. But here, yeah, in a similar way, we're gonna uh, give the user a chance, whether by giving a random integer between 0 and 1. If it gets 0 or 1, if he gets 0, he gets player 1, or if he gets 1, he gets player 2, something like that. So let's just import, and let's define a function. Let's choose first. Then, so if the flip turns out to be equal to 0, so yeah, so if the flip, yeah, so if the flip turns out to be 0, so then we're going to return saying that he's player 1, else is player 2. We'll return saying that he's player 2. So yeah. And now we'll check the function choose first. So we didn't actually define what was going to flip was going to be. So we are taking flip to be a random integer from 0 to 1. Yeah. So now let's try it out. So here you can see it randomly chooses it got 0, and here you get the output to be player 1. You have got player 1. So next we have to write a function. So returns a boolean value saying true or false based on, and to check whether there is space available in that position. So let's write it out. So before that, let's modify our board in such a way that there is a space available. So let's make it X. So O, then we'll make it X again. Yeah, here we are going to give a space, and we'll make it X again, and oh, so we are providing the space. So next, what we are going to do is we are defining a function space check. We're defining function space check, and based on board and the position, we're going to check whether there's space available in that particular position, and we are going to return the board with the position, which is, yeah. So next we are going to run space check, the function space check. As you can see, it's indexed at position 8. Here it's indexed at position 8, so we're going to check with 8, and here you can see that it returned true. So when we check with some other position, it's going to return false, so we'll keep it as 8. So now we write a function to check whether the board is full or not, and if it is full, we are going to return the boolean value true or else false. So first let's start with the defining a function. So we're gonna check the board. So let's name it as full check board, and then so is full. So is full, it's gonna be true. So for I in board, if I is equal to so is so if there's a space available, so is full will be false, and we're gonna return sorry, yes full. Yep. So now we'll check board and board. Yeah. Here it's showing false. So now we are gonna set in the range for that, for the full board check, and so it is in the range from 1 to 9. So index 1 to 9. So for that we are going to specify the range from 1 to 9. So which is 1 to 10 in the sense this is n minus 1. So it is starting to n minus 1 in this case. So next we are gonna check whether there is space in the board.
then we're gonna return false, or we're gonna return true. So now we're gonna go check board, and we will check the board. So yeah, so next we are going to write a function to ask the user which position is going to choose next after this particular step, and also check whether there's spaces in this thing present in that particular position. So let's start with writing the function. So we're going to write the function like define next player's choice, and board. So the next we're going to initialize the position starting to be 0, and then we're going to iterate it through a while loop. So while not position in the index, which is 1 2 comma 3 comma 4 comma 5 comma 6 comma 7, right? So this is going to be the index, and or not space check in the board position. So we are going to allow the user to enter his input. So we're going to say user and ask his input. So enter your next position. So next we're going to return the position. Then we're going to print next player's choice, and we're going to print saying board. Yeah, so the user will ask you to enter your next position. Suppose I enter 100, I can enter one more, so I'll enter 10. So I can enter one more, I'll enter 6. So I can enter 5, then 4, 3, 8. So it takes in a number and it checks whether this space check is there, and it will give me the next position, which is number 8. So next we are going to define a function with replay, so that whether the user wants to play the game again or not, and asking the user whether he wants to play it again or not. Then we're going to return input, saying that do you want to play again? We're going to ask the user whether he wants to play it again, and the answer will be either yes or no. Then we're gonna use the dot lower method, so that if he mentions a lowercase letter also, no issues with that. So starts with, and we're going to mention y. Yeah, so if yes, so we're gonna use the replay option. So I'll just type in yes. Okay, sorry. Okay, there's an error here. It's dot lower. So the now when I try, yeah, now it's showing true. So the user can play the game again. So this is just the algorithm or the basic things you need to know in order to create the game. In the next video, I'll be explaining in detail how to create the game step by step. So I hope you guys understood all these methods in order to create the game. These are the essential methods in order you need to know in order to create the final game. Now we are going to write the entire code where all these steps are integrated in a single code. So let's start with the final arrangement of the so yeah. So first, let's assume that we are running a while loop throughout the game, and considering while as true, taking board into 10, so the space check from 0 to 9. So this is same as, instead of writing this, you can also do this, the initial method, which is this. Yeah, this is, both are the same, just that it's a much more simpler. Instead of writing so much, you can just write a cell and into 10. So this is much easier compared to that. So next we are going to create markers for player 1 and player 2. And we're going to say that it is going to be the player input, whether it's going to choose player 1 or player 2. So the turn is going to be the function which we have already seen in the previous video, choose first. Yeah, and we're going to print saying turn plus will play first. So here it will automatically choose which player you are. It automatically choose which player you are based on the choice, and directly decide who will play first. So next we are going to take saying that play game. So, and we are asking the user saying that are you. So we're asking the user whether he's really ready to play the game, and we're going to give him option saying yes slash no, then user dot lower, so that, yeah, so this is for this thing. And if play game, so if the play game is continue to be true, game on is true, the game continues. Else game on is false, it discontinues there. So next, so we are iterating through while loop, which is for game on, so whether the game on should be true or false. So iterating to the while loop, and now we'll start with the player 1. We'll start with for player 1, then we'll say if turn chooses player 1. So if the turn chooses player 1, then second, yeah, choose player 1, we have to display board. Then we have to choose the position where it's going to start, and that would be the player's choice. That's going to be the next player's choice. We're going to check space check throughout this thing and select whether this thing is on, and then we are going to use the marker to position to find the position of the player. And if win check, we are checking for whether the player 1 will win the game or not. So we are entering position and no, not position, then we get player 1 marker. Yeah, player 1 marker. Then we're going to display the board again. And we're going to print a message saying that player 1 has won the game and congratulations. Yeah, so this will be the message which has been displayed, and here the game on would be false. Next we're going to see for the else statement. You're going to check the entire board, and we're going to display the board again. And if this happens, say the game is draw, and enter a message saying that better luck next time. Yeah, and next we are going to break out of the loop. So when it breaks out of the loop, it will go to the second player. Now we're going to write the code for the second player. So now let's look into for player 2. So it's just the same as player 2, player 1. Just will make some changes. So we'll just copy and paste it, and we'll just make some changes. We'll make it player 2, and yeah. So here it will go to player 1. Then if not, replay, then we'll break. So I'm going to start. I implemented the code, and now it's asking me to enter a marker. So I'll be entering X. So I'm player 2. So first let me enter 2, and x1, and it's player 2's chance, player 1's chance, so and 3, and now I want x to win, so 4, and now 5 and 7. Here you can see that player 1 has won. I want to play again. Do you want to play again? Yes. Now I want to check what happens when the game is draw. So I'll take the marker to be O. So I'm player 2. Yes. So 1, then 2, then 3, then 5. So I want to block O from winning. So I'll be giving 8. So next is 4. So I want to block O from winning again. So X. Now I want to block X from winning. 9, and the last position 7. Here you can see the game is draw. It's showing better luck next time. So it's asking again, do you want to play again? So I'll say I don't want to play again and no. So the now it's exited out of the loop and stop the game. So I hope you guys understood the following exercise and how to implement this, and I want you all to try this on your own so that it's very much interesting and fun. Hello guys, welcome to the Python series. In today's video, we are going to look into a very interesting topic, which is object-oriented programming, or OOP. So let's start with the introduction of object-oriented programming. So object-oriented programming allows programmers to create their own objects that have methods and also attributes. OOP allows users to create their own objects. In general, OOP allows us to create code that is repeatable and organized with the help of objects. So when you generally look at the format, it is often very confusing, and its usefulness may not be completely clear at first. So when you're looking at larger scripts of Python code, functions by themselves aren't enough for this repeatability and organize. So in order to correct this, we are using objects or object-oriented programming to make it more clear and impactful. So commonly repeated tasks and objects can be defined with OOP to create code that is more usable in this case. So the syntax for object-oriented programming is uh, here we are using the class keyword followed by the name of the class. Next, we are defining a method which is init, which is instance of that actual object. And in the brackets, we are mentioning the attributes. First, we have self. Self is also known as the instance of the object itself, and parameters, which are param1 and param2. It is not mandatory that you mention two parameters, or you can also use more than two parameters, three parameters or something, but one parameter is more than sufficient. So followed by the next line, you have self.param1. So initially when you pass a parameter, you need to assign it to the attribute of function. So here you're assigning it to a function which is self, which is part of the object self.param1 equal to param1. The next followed by the next line, we have self.param2 equal to param2. Then now next in the further case, we are defining another method, which is some method in this case, and here we use the self, which is related to the following class. So then we are printing the object, which is the attribute, which is part of the object self.param1. Now let's try some examples on attributes and object-oriented programming. So let's start by creating a class named dog. Then we are gonna define function known as get name. And we're gonna print saying that the name of the dog would be Tommy. Then we're gonna define another function saying get age, and we're gonna print saying it's 1. Then we're gonna define another function get action, and we're gonna print saying that Tommy say barks. So you say box. So each time you uh, mention a function, you have to pass in the self parameter. So self tells the class which object I'm in and which and where I'm going to try to apply the function on. So here I'm using the self. So now let me assign a variable d to the function d to the class dog. And now when I try d dot get name, I'm going to get Tommy, and now d dot get so I'm just gonna say try to use d dot get age 1. So d dot get action, it's gonna say box. So what if I wanted to pass more than one parameter to an class or an object? So we are going for doing that, we are going to use the init method. So we can create more than one parameter. So first let's taking the class dog, then we're gonna say define init, and we're gonna pass in self comma name comma then we're gonna say self dot name equal to name, then self dot age equal to age, and self dot action equal to action. So now we are gonna define function get name. We're gonna pass in self, and we're gonna print saying that the dog's name is, and I'm gonna say self dot name. Next we're gonna create another function def get age, and self gonna print the dog's ages, self dot age. So the next the function get action, and let's say so print. Now here we're gonna use something different, so we're gonna say self dot name plus self dot action. So here both of them correlate to each other. So now let us try to update the details of another dog. Let us say that the name of the new dog is, the variable assigned is d1, and dog, the name of the dog is Jimmy, and age is 1.2, and let's say barks. So now what we're gonna do is, let us say d1 dot get name. So it says the dog's name is Jimmy, and when you try d1 dot get age, say the dog's age is 1.2. Now let's try d1 dot get action. So it says that Jimmy barks. Hello guys, welcome to the Python series. In today's video, we're going to do an example problem on object-oriented programming. So the problem statement we are given is that in cricket team comprising of players for the playing 11 from different states of India, the team committee wants to know the average runs scored by each individual batsman scored in 3 matches from the team. So in this program, first initially we'll be restricting the number of players playing to 11 because the maximum number of players playing for a cricket match is 11 players, and then we're going to find out the average score scored by all of these players. So now let's do some examples on example problem which is related to OOP. So first, now in this problem we have to find out the average of the score which has been scored by all the players in a team. So first let's start off by creating the class. So the name of the class here. Then we're gonna define it. Then we're gonna start with self, name, age, then state, then score. This is going. So then we're gonna say self dot name equal and self dot age self dot state to state, and self dot score equal to. Then we're gonna define another function get score. Gonna dot score. Now then we're gonna create a class. Then we're gonna define it. Gonna say self comma maximum layers. Then self dot self dot maximum layers maximum layers self dot layers. Gonna put in list and it's gonna append each time you add some layers into it. List. So then gonna define add player here. Then if then is self dot player self dot player player is less than self dot max players. Self dot players is less than self dot max. Then self dot players dot append. We're gonna append this. So here, then for this we are going to return saying it's true. Else, if it exceeds the number of players, then we're going to return saying false. Then we're going to stop it right there. Then we're going to find get average per self. Now we are going to make the score 0 for player in self dot players score less or equal to player dot get score. So we're return gonna return the score by length of the self dot. So score, we're gonna return the score with the whole total score by the total length of the place. That will give us the average of average score. So this is done. The Yeah, now this is done. So now we are going to add in the players, the data of the player. First, we're going to create a player. So let us name it as player 1, and the player, for example, let us say a first player's name is Stephen, and his 19, and state he's from Kerala, and for let's code in player 2 dunk. Let us just the players. Gonna add this. Yeah, these are some of the list of players we have created, and now we're gonna add these players into our team. Create the team. Let's say the name strikers 11, strikers 11, and maximum number of playing. Now we're going to add in the players. So here you can see that we can add until 11 players. So it shows true. So if I try to add in one more player, so let's say player 12, it will show false. So when I add in 11 players, it will show true. So let's continue with this. And now let's print out the average score. So based on the scores we have given, we have modified the score to be the aggregate of all the number of scores. Then we are going to then now we are going to print team dot get average score So here you can see that average score is 662.54 from the playing 11. So until here is the playing 11. So average score is 662. Yeah, that seems. Yeah. Guys, welcome to the Python series. In today's video, we're going to look into the methods in object-oriented programming and discuss more in detail on the method inheritance. So the methods are functions defined inside the body of a class. They are used to define the behaviors of an object and also the properties of an object. So the main aim of object-oriented programming is to bind together the data and the functions that operate on them, and so that no other part of the code can access this data except that particular function. So the types of methods in object-oriented programming are as follows. First is inheritance, encapsulation, polymorphism, and abstraction. Now, in this video, we're going to look into detail on inheritance. So inheritance allows us to define a class that inherits all the methods and properties from another class. So this another class is known as the parent class, where parent class is the class being inherited from, or also known as the base class. Child class is the class that inherits from the parent class, also called derived class. The types of inheritance are single inheritance, multiple inheritance, multi-level inheritance, and hierarchical inheritance. So single inheritance is when it involves one child class and one parent class. Multiple inheritance where it involves more than one parent class, where child class is incorporated with the parent 1 class and the parent 2 class. And multi-level inheritance is where the child class acts as the parent class for another child class, where it acts as an intermediate between the parent class and the child class. Hierarchical inheritance is where you have more than one derived class that are created from a single parent class, where you can call there's one parent class and two child classes. So now let's do some examples on inheritance. So let us take a class. So I'm going to name my class as dog. Then I'm going to define function and pass in self. And I'm going to say print this is the parent class. The next I'm going to define a function as the bio, which will hold all the characteristics or the bio of the dog, like name, age, the character, and I'm gonna say self dot now I'm gonna call now let's attribute print saying that this is the child class. Then we're going to find paste here.
So we are expecting an intent. So then we're gonna say X Labrador. Gonna show both. This is the parent class and also the child class, because the child class is incorporated with the parent class. So it's gonna show both. So now we are trying to get the bio. For example, gonna say Oscar. Name of the dog is Oscar and 3 years old. Trusting. Here you can see Oscar. Name is Oscar and age is 3 and character is trusting. So now let us create a class by Husky and the dog. Then we're gonna define self, name, and age. And let's say dog, but self dot name self dot age. Then you're gonna define a function. Say welcome. Gonna print that pet is so now when I assign variable y, gonna mark y dot welcome. So here it's going to show hi, this is the parent class. So this is the parent class which is derived from dog. So that is parent class, and welcome. It will show the message saying that hi, this is my pet Mark. So need not mention that. Right, I guess. So yeah, here you can see that it prints out a sentence saying that hi, this is my pet Mark, and his yeah, true, and mention age. This is my pet Mark, and he's 2 years old. So I hope you understood all the concepts in this video. Thank you. So now let us look into the types of inheritance which can be used. And first, let's look into the single inheritance, where let us create a class dog. And so here you can see this is an example of single inheritance. Yeah, let me show you. And uh, let us define a function and name it function one and itself. And we're gonna print saying that this is the parent function.
Now we're going to create another class, Labrador. And we're going to define a function to self print, saying that this is the child class. And now we assign a variable to class Labrador. Try to access the function. So here it will show that this is the parent function. So it has inherited with the parent class. So next we are going to look into the multiple inheritance, where let's say we have class dog. Yes, we are going to add another class as class. For multiple inheritance, just we're going to add one more class, which where we are having two parent classes and one child class. So we're going to add one more parent class, which is going to name it as pet. Kind of function it as function 3. Going to print that this is the parent function. Going to run all of these. Now we're going to make some changes to Labrador. Include the pet class over here, and when we're going to run this, so it runs this, and if we try to run even function 3, so yeah, we can also call function 3 in this, saying this is the parent 2 function. So next we are going to look into multi-level inheritance, where just we are trying to inherit trying to make one parent class, and one parent class acts as an intermediate. So you're gonna mention the parent class here and this as pet. So when we try to print function 2, so it will show this is the child class. So here in multi-level inheritance, where Labrador inherits the properties from pet and pet inherits the properties from dog. So hence each function is in correlated. So by giving you this output. So next we're going to look into hierarchical inheritance. So here we're going to make it as dog, and we're going to add new cell, and gonna also try for the pet new variable for the parent2 class. And when you're gonna run function one, this is the parent function, and when you run the so here you can see that while you run both Labrador and Pet, it will show that it is inherited to the main class, which is the dog class. So here, this is an example of hierarchical inheritance where all of there is one parent class and two child classes. So here, Pet acts as a child class. So now let's look into the hybrid inheritance. So now let's look into a hybrid inheritance where we are having another parent class where we're gonna name it as breed, and we're gonna define as function 4, and we're gonna print saying that this is parent 3 class function, or we're just gonna have Labrador inherit one more which is breed. It's going to inherit both the function properties of the dog class and also the breed class. So now let's run this, and we can see that this is 4, and we try to add new cell, and when we try to access x dot function 4, we're also able to access the parent 3 function, and we are also able to access function 1, which is function 1 is of the dog class and function 4 belongs to the breed class. Guys, welcome to the Python series. In today's video, we're going to look into a method polymorphism from object-oriented programming. So polymorphism is taken from the Greek word poly, where poly means many and morphism means forms. So it means that the same function name can be used for different types. So this makes the programming more easier and intuitive. So polymorphism in Python defines that the methods in the child class that have the same name as that of the methods which are used in the parent class. So in inheritance, when you see the child class inherits all the methods and the properties from the parent class. So in here, it's also possible to modify a method in child class that is inherited from the parent class. So a child class inherits all the methods and the properties from the parent class. However, in some situations, this method inherited from the parent class doesn't fit into the child class. In that cases, you will have to re-implement the method in the child class. That re-implementation is known as method overriding. By using the init function, you'll be able to that is a possibility where you'll be able to override a particular method in both the parent class and the child class. So now let's do some examples on polymorphism. So let us create a class. Let's say dog, and next we are going to define it, and let's say self comma name, self dot name equal to name. Next, we're going to define other function which is known as speak self, and we're going to return self dot name plus, and we'll say that um, dog says woof. So now let us create another class for cat. We'll just copy this, and instead of woof, the cat says now. And let's just find this. And we're gonna name our dog as Charlie and cat as Luna. So now let's try to print Charlie dot speak. Gonna print saying that Charlie says woof. So we just have to mention over here, and so now let's try implementing this. So here you can see that Charlie says woof. Let's remove this. Try to, yeah, now it says Charlie says woof, and let's try that same thing for Luna. Here it says Luna says meow. So next, we're going to try to put is both under the category pet, both the cat and dog under the category pet, and we're going to create a list. We're going to include both Charlie and Luna in the same set of list, and we're going to print type of the pet. Then we're going to print pet speak. So here it says print pet speak. So we're going to delete this. Yeah, now we're going to implement. Yeah, here it shows that classes main dog and this is cat. Now we are going to define a function known as pet.speak. Going to put it under the pet. Going to print that pet.speak, and now let's pets for Charlie. So here it shows that Charlie says woof. So here we are considering both Charlie and Luna as one of pets under the category pet. So when we try to iterate speak in pet, so this is one of the advantages in polymorphism, where we can use the same function speak in both in the class dog and class cat, and also in this where we are using in this function pet speak. In pet we are going to use the function speak. So next we are going to try pet speak for Luna. So here it shows that Luna says. So now we are going to inherit these both classes, the dog and the class cat in the class. So now we are going to inherit both the classes, the dog class and the cat class, into a parent class or the base class, which we're going to name it as animal. This is going to be the class or the parent class, and we're going to define in it, and we're going to say self dot. So the same function we are going to use in this also. Week. So we are going to raise an error saying not implemented, not implemented implemented error. And I'm going to say that subclass must implement this abstract. So this is going to be an abstract where the subclass, where the child class also should be implement this method. So now we're going to implement the dog class in the animal class, which is inherited from the animal class, and we're going to create a function. We're going to use the same function, peak, and we're going to return self dot name. Going to be a class dog, and next we're going to animal, and we're going to create in the same class self. So and we're going to return saying that. So now when we trying to create an object where, let's say, name of the dog is going to be Max, and it and name of the cat is going to be Fuzzy under the class cat. So now when you're going to print, we're going to use the same method where we used earlier, the speak method, and we are going to try to here you can see that it's a Max says woof, and you're just gonna add some space, and it says Max is woof, and we're gonna try in the same where the dot peak. Here you can see how it is fuzzy, and here you can say that fuzzy says meow. So this is what this is the main advantage of polymorphism, where we can use the same function in multiple classes, and which can be derived from. Hello guys, welcome to the Python series. In today's video, we're going to talk about encapsulation. Encapsulation is one of the methods which can be used in object-oriented programming. So it is nothing but it's hiding the data outside an object or outside a class and restricting the data access. So in order to restrict these accessible variables and methods directly, and this can prevent the accidental modification of data. So in order to do this type of restricting the data access using function is nothing but encapsulation. In order to know more about encapsulation, we first need to know what is access specifiers. So in other object-oriented programming languages such as C++, Java, there are some variables which are used to determine the access control for a specific data. Like these can be access modifiers are public, protected, and private. But in Python, you don't have that variable, such variables. So in Python, you use the underscore symbol to determine the access control for a specific data member or a member function of a class. So for example, for public, you're not going to use any underscore, and it is accessible through entirely throughout the program. And for protected, you're going to use a single underscore symbol. And for private, you're going to use two double underscore symbol. So a class in Python has three types of access modifiers. First is public, where the data can be accessed throughout the program. Protected is, you can call it semi-private, where the data can be only accessed through the class and the class which is derived from it. And in private, you can only access the data within a class. Now let's do an example on encapsulation. As in previous videos, we're going to use the class dog, and we're going to define init function. The parameters we're going to pass in is self, age, and breed. And we're going to set self.age equal to age and self.breed equal to breed. And now what you're going to do, we are going to define another function which is set age, and pass in parameters self and value to retrieve the age of the class. And we're going to say self.age equal to value. Another function which is get age, pass self, and we're going to return self.age. So now what you're going to do is you're going to take the details of the dog, and we're going to name it as Max. The age is 7 and breed is Labrador. Next, we're going to take another dog, Oscar, and under the class dog, age is 4 and the breed is Husky. The next dog is Charlie. Age is 5 and breed is Dalmatian. What we're going to do, we're going to set age of Max to be 6 instead of 7. So what we're going to do is going to use set age. We're going to make it as 6. So now we can see that when we try to print max.age, it's going to show 6. So if you also try max.age equal to 7, when we print max.age, it's showing 7. So we have to prevent this data being changed by using the equal to symbol. So in order to do that, we have to use access specifier and make it private. So now let us learn how to use access specifiers. So now let us do some example in order to know how to use access specifiers and make it data accessible. And now let us create a class known as access. I'm gonna use the init function, and pass in the parameters self and name. And we're going to say that self.a is 1. This is a public variable. And when we have self._b, and this will become a semi-private or the protected variable. And next we're going to make this c as a private variable. So now what you're going to do is we are going to assign a variable to access name. And what you're going to do is we are going to print x.a, which will print out saying the output as 1. And next we're going to try and print x._b, which will give you the output to be 2. And when we try to print x.__c, it's going to show that our access object has no attribute under underscore c because it is a private variable. It has been converted to private variable, so we will not be able to access it. So now let's try to implement this access specifiers in our encapsulation example. So now let's try to change this self dot double score age, and here you can see that this is set. And when we try to print, try to set age as __ age equal to, so when we implement max.__ age is equal to 7, we are not able to change this thing using the underscore age 7. So when we print max.getAge, so it's showing 6. We will not be able to change the value by using the __ age. So hence can only use to retrieve and change the value using the set and the get method. So in order to, so when we try to find out the breed and we try to change it to, suppose let us say husky, so it shows that dog object has no attribute get breed. So here you can see that uh, so we have to make a get and set method for even for breed. And when we just try out breed, so in order to call these, we are going to create an get and set a method for breed also. It says set breed, and we're going to say that self dot breed equal to value, and define get breed self comma value is self, and we're going to return self dot underscore breed. So when we try to change it, and we are now, let's try to print max dot get breed, it's still the same. It's still a Labrador. So we'll not be able to use the private variable, the public variable to get the updated one. So in order to update, we have to use the set method. And let's now try to use the set breed and we're going to change it to, let us say, husky. And now let us try to print max.getBreed. So here you can see that when we print max.getBreed, it has been changed to husky. So here you can see that we have converted this into husky. So what we have to do is, how can we access the private variable? So what we have to do is, while accessing the private variable, we have to mention max dot underscore the name of the class, which is dog, then underscore underscore breed. So by doing this, we are able to access the class. So if I just try to say we are going to do it as underscore underscore breed, it says that dog object has no attribute underscore underscore breed. In order to access that, so this private variable is only accessible within the class. So it can't be accessible outside by using any other object or something. So for example, if you want to change, let us say that max dot underscore dog underscore underscore breed is equal to Labrador again. So when we try to access in the conventional method, underscore underscore breed will not be able to be accessed. So in order to accessing this, now we have changed it back to Labrador. So the only way to access the private variable is to mention the name of the class by underscore a name of class and the private variable. So this is how you restrict the data access using functions in encapsulation. Hello guys, welcome to the Python series. Today's video we're going to talk about what is an abstract class and an abstract method. An abstract class can be considered as a blueprint for other classes. So it allows you to create a set of methods which are abstract methods that must be created within any child classes or subclasses which are built from the abstract class. A class which contains one or more abstract methods is called an abstract class. So when we are designing large function unit with functionality where the functionality of the abstract class has been inherited from the subclasses, we want to provide a common interface for the different Let's take an example of a common application programming interface API for a set of classes. Here it is a programming interface where the computing that defines the interactions in different applications. For example, a set of applications has been taking the function procedures from a particular function application has the access of data and other features from that application. So these set of applications has access to that one application which can be considered as an abstract class. All the data or the features of that particular application inherited by those other applications. So this is what we call an so now let's talk about the abstract method. Abstract method is a method that is declared but contains no. So abstract classes may not be instantiated, but its abstract methods must be implemented by its subclasses. Otherwise, it would not run, not initiate anything, any functionality from the abstract class. So hi guys, now we're gonna do one example abstract class and abstract method. So first, I'm going to start off with going to create a class person. Gonna say that gonna define a function named action, and we are just gonna say pass so that I'm not going to pass in more arguments. So I will just say pass or any other process to be run. So I'll be assigning this person class to I try to run this that when I also call just runs. So we have found that this is not a abstract class. This is just a normal class. So in order to learn how to make it into an abstract class, we just have to port a method, port a module from package E. Let's say we are gonna module and also a method which is associated with as the abstract method with method which you inside the abstract class. So and next what we're going to do is we're going to this class which we have created earlier to an abstract just by mentioning the module package and then we're going to define the singular function saying self and we're going to pass it out. So now when we try to run the similar set of statement trying to call class. So, and also in order to implement an abstract class, we have to um, do within the class, which is at base class, and so a decorator act method is a module which we have already quoted or to associate with the abstract base class. A decorator is nothing but a line pattern which adds functionality to this existing class or the code without modifying the entire structure. So in order to inherit or applies the abstract class or the, then try to run this, it will show me the error saying that it can't initiate abstract class person. So in order to use this abstract method, we need the class which creates with this abstract method, inheriting this class or the, so let us create another class which let us name it as man, and we're going to inherit all the abstract method class. So let us say that we're going to define the action saying self and let us say pass. Not in let us say the action to be going to print the actions that uh, walking. So let the action be walking. So what now? What I will do when I try to print this, let us given another. Let us assign a variable to class man and say that dot action. Now you can see that it has included a abstract method which is action parent class is person, and now there's a statement print function which does this function and to the action. So now let us try including one more method abstract method into the let us say create another and let us define let us say a character. And now let us include character, a character of the person. So when we try to print this b dot action, you can see that it's working. As we earlier checked that action is working and it's abstract method from the class person. But when we also try character, it also works fine, because how much ever methods, abstract methods we are going to make as parent class or the abstract class, that same method will be mentioned in this subclass, or you can call it as the concrete class, is inheriting the abstract methods from this class. So in order to call a particular function by a single method instead of implementing all these given classes, if you have, suppose we have only two methods, abstract, we have more than five, six, and if you want to mention all of these to this single class, how do we do that? So here we have only two abstract methods which are present in the person class and a concrete class, or the class man named man. So if we have like more than five or many abstract methods, so we also have to incorporate those in these subclass. So it would be difficult for us to mention all of that. Instead of doing that, we can find, let us say we let us create a class named Ravi, and just assign it to the parent class or the class person. Gonna find the say his farmer, so a function named farmer and itself. So we're printing out a statement that he passed this. What we are doing here is call, we're going to assign this particular class Ravi a variable named. Here you can see that it gives me an error saying that can't instantiate abstract class Ravi with abstract method action. So here it doesn't have that particular um, function which is action which is present as we didn't find that. In order to do this, we have to mention the whole entire functionality of that class. To that, not just mention about the class or inheriting it. We have to mention the functionality of the structure of that particular class. So in order to do that, we mention a. So here, entire abstract methods would be incorporated, stored this variable a. The entire functionality of this abstract class would be stored in the person class. So now if we try to incorporate that and try to assign it and try to give it in this function, let us try to run that. We mention itself plus a, and when we try to um so here you can see that it's working fine, and the output saying that he's working. So here you have to understand one thing, that when we just mention or inherit from the abstract class, not be giving output, is just inputting the attributes of the class, but you're not in the functionality of the entire class. To do that, you have to mention the entire functionality of the class by incorporating this variable assigned to this. Hello guys, welcome to the Python series. Today we are going to talk and discuss about a topic known as exception handling. Python, whenever some error message shows up or something goes wrong in the program, there's an error message which is showing up. So these error messages are nothing but the built-in exceptions that are raised when your program encounters this particular error. So when these exceptions occur, the Python interpreter stops the current process and passes it to the calling process until it is handled or sorted out. So if it doesn't be handled or it doesn't sorted out, the program will crash. For example, let us consider a program where we have a function A that calls function B, which in turn calls function C. If an exception occurs in function C, but it is not handled there, the exception passes to B and then to A. If it is never handled, an error message and a program comes to a sudden unexpected halt. So in order to deal with this, to handle the error messages and to get an intimation before this error message occurs, we use these exceptions which are like can be handled using this set of state try, except, raise, finally. So when exceptions can be handled using a try statement, so the critical operation which can raise an exception which is placed inside the try clause, the code that handles the exceptions is written in the except clause. So, and exceptions are raised when errors occur at runtime. So, by runtime, we can manually raise exceptions with the raise keyword. So, in the try statement, also have an optional finally clause. So, in this clause, statements under this executed no matter what and is generally used to release external. Now, let's do an example on try and X. First, let me take a variable and say that thing and to, let's say, ask the user to enter his first number. So let me say like enter 10. Next, we're going to ask the so let's say we're gonna get the division for let's say and here you can see that it would just give you the direct output without any problems. What now going to the topic of that recently enter something wrong or something goes wrong with your program or something, there would be some error messages which show. These error messages are nothing but the built-in exceptions that are present in the Python program itself. So when the error message occurs, the process which you are undergoing stops right there, and it asks us correct that mistake, then proceed further. Before even getting to these error messages, what if we could get an intimation saying that the the name which is entered is wrong or the variable which is signed is wrong or something? We could use that try and accept help us in that case. Let us try using this try and accept. Let us say if is be the first input which the user take and one. So now we just have to print whatever is all formatted. In the case of AB, that case we use the let's say that the output which has been retrieved, the finalized output on after get values of format. So now when we try to enter our first number, let's say 10, so we would receive the output to be 5. So let's try this and let's I would enter 0 in this case. My second number to be 0. So you would say that error message has occurred. So we would want to know what is that error message. Basically, what you try to do is I run this case, like enter my number to be 10. When I run this, let me try 0. So here you can see that it like occurs as 0 division. So this is a zero division error. So we would have got that exception be a 0 division. I've already got an indication that the error which you have error which that could get an intimation that we can correct that number not by now when we try the same here you can see that it will that the number is not next. What we do is if we change this variable instead of a and b, that's what happens. So here you can see pops up and other exception. It's saying that name error. What we do is another exception. We have to create this name to print that variables have not variables entered not defined. Enter this. We try the same. Here you can see that variables entered how we got and so now if I try to do this one more, try 10 and let's try some value. So just show me that there's a value error saying that invalidated for int. So found another exception which is value error. So let me take this down. I can say valid data type. So now when I try to execute the same, say invalid data type has been entered. So now one more thing which I can try is that so if my first integer value of first input turns out to be a negative integer or a negative value, and let's say I'll not be using those kind of values, so I can raise an exception that would be a type error, and whenever I try to execute it, let us say I minus 10 and let it be any other value, so it would show me that type error. So what I would do in this case is that I would write as except type error. I would say I would like valid. So now when I try to same and check it out, say that it's valid input. So that's how you try and accept. So if this doesn't work out, what we can try is a method as finally, regardless the error which is being. So regardless the error, error message, this would print. So whatever the error message, I let's say I take out this name error. So let me try to do it. Here you can see that this x y are not defined. So you would get a name error. Turn this also would be printed finally. So regardless the error message printed later on. I hope you guys understand